You are listening to Amazon S3 for Developers, a practical guide to cloud storage and beyond. Like and subscribe to keep up to date on our latest audiobooks. Amazon S3 for Developers, a practical guide to cloud storage and beyond. Chapter 1, Getting Started with Amazon S3, the foundation of cloud storage. Every towering structure begins with a strong foundation. In the cloud, for countless applications, that foundation is Amazon S3. Before we dive into the intricacies of specific features and advanced integrations, it's crucial to grasp the fundamental concepts that define S3 and distinguish it from other storage services. 1.1 What is Amazon S3? The simple storage service. Launched by Amazon Web Services, AWS. In 2006, Amazon Simple Storage Service, or S3, revolutionized how businesses and individuals store and retrieve data on the internet. At its core, S3 is an object storage service. But what does object storage truly mean, and why is it so significant for developers? Unlike traditional file systems, like those on your computer's hard drive or block storage, often used with virtual servers, S3 doesn't deal with nested folders, raw disk blocks, or specific operating system paths. Instead, it stores all your data as flat objects within buckets. Think of it like this: traditional file system. Imagine a physical filing cabinet, your server's drive with folders inside folders, directories containing individual papers, files. You navigate a specific path to find a document, e.g., C, /users /John /documents /reports /Q 12023 docx. Object storage, S3. Imagine a vast, infinitely expandable warehouse. Instead of folders, you have unique named containers called buckets. Inside each bucket, you place individual objects. You retrieve an object not by its path, but by its unique key, which acts as its name. For example, Q 12023. docx might be stored in a bucket named John's Reports, with the key reports 2023/Q 12023. docx. The folders here are just part of the object's key and don't represent actual file system directories. This flat structure, combined with S3's design principles, confers immense benefits. Virtually unlimited scalability. You don't provision storage, you simply use what you need. S3 scales automatically to handle petabytes, exabytes, or even zettabytes of data. Extreme durability. S3 is designed for 99.999999999%, 11 nines, of data durability over a given year. This is achieved by redundantly storing your data across multiple devices in multiple facilities within an AWS region. This means that if you store 10,000 objects in S3, you can expect to lose only one object every 10 million years on average. This level of resilience is astounding and virtually eliminates concerns about data loss due to hardware failures. High availability. Objects stored in S3 are readily available for access. S3 is designed to sustain the loss of two facilities concurrently. Robust security. S3 offers extensive features to control who can access your data, how it's encrypted, and where it resides. This includes detailed access policies, encryption at rest and in transit, and advanced network controls. Cost-effectiveness. You pay only for the storage you consume, the requests you make, and data transfer out of S3. There are no upfront costs or minimum fees. S3 also offers various storage classes tailored to different access patterns, allowing you to optimize costs significantly. Performance. S3 is engineered for very high request rates and low latency, making it suitable for demanding applications like media streaming, big data analytics, and high-traffic websites. 1.2 Core Concepts. Buckets, objects, and regions. To effectively work with S3, you need to understand its three fundamental building blocks: buckets, objects, and regions. 1.2.1 Buckets. The containers for your data. An S3 bucket is the fundamental container for data stored in S3. You can think of it as a logical grouping or a top-level folder for your objects. Every object you store in S3 must reside within a bucket. Global uniqueness. Crucially, S3 bucket names must be globally unique across all Oz accounts in a specific Oz partition, e.g., Oz, OzCN, OzGovCloud. This means if someone else has already named a bucket My Company Data S3, you cannot use that exact name, even if it's in a different region or a different AWS account. This global namespace ensures that URLs pointing to S3 objects are always unique and unambiguous. Region specificity. While bucket names are globally unique, each bucket is created in a specific AWS region. For example, you might create a bucket My Unique Application Assets in the US East 1, N Virginia region. All objects stored in that bucket will physically reside in US East 1 unless explicitly replicated to another region. This choice of region impacts latency, cost, and data residency compliance. Bucket ownership. The Oz account that creates a bucket owns it. Ownership remains with the creating account even if objects in the bucket are written or managed by other accounts. 1.2.2 Objects. Your data in S3. An object is the fundamental entity stored in an S3 bucket. It consists of the actual data you upload, e.g., an image, a video, a document, a backup file, and metadata describing that data. Key value pair. Each object is uniquely identified by a key within its bucket. The key is essentially the object's full name or path within the bucket. For instance, in a bucket named My Photos, an object's key might be vacations/Europe/Paris/Eiffel Tower 001.jpg. While this looks like a file path with folders, S3 doesn't actually have a traditional directory structure. The slashes, / are simply part of the key name that S3 interprets to create a hierarchical view in tools like the AWS Management Console. This allows for logical grouping and easier management. Metadata. When you upload an object, S3 stores metadata along with the data. This metadata provides information about the object itself. There are two types. System-defined metadata. Information S3 automatically maintains, such as the object's creation date, size, content type, e.g., image JPEG, and storage class. User-defined metadata. Custom key value pairs you can associate with an object during upload. For example, you might add project, new app or userid, 12,345 to an object, which can be useful for indexing, tracking, or application logic. Size limits. Objects can range in size from 0 bytes to 5 terabytes. For objects larger than 100 megabytes, S3 recommends using multi-part upload, a feature that allows you to upload an object in parts simultaneously, significantly accelerating uploads and improving reliability. We'll delve into this in Chapter 5, 1.2.3 Regions, where your data resides. Oz regions are distinct geographic locations where AWS hosts its services. Each region is composed of multiple isolated locations known as availability zones. When you create an S3 bucket, you choose the region where it will reside. The choice of region is important for several reasons. Latency. Storing data closer to your users or your compute resources, like EC2 instances or Lambda functions, can significantly reduce network latency, making your applications faster and more responsive. Compliance. Many industries and governments have regulations regarding data residency, specifying that data must be stored within a particular country or geographical area. Choosing the correct region helps meet these compliance requirements. Cost. S3 pricing can vary slightly between regions. Service availability. While S3 is highly available, not all AWS services are available in every region. If your application relies on other Oz services, ensure they are also available in your chosen S3 region. 1.3 Accessing S3. Your first interactions. As a developer, you'll primarily interact with S3 programmatically, but it's helpful to understand the various ways you can access and manage your buckets and objects. AWS Management Console, a web-based user interface that allows you to manage your Oz resources, including S3 buckets and objects. It's excellent for visual inspection, initial setup, and troubleshooting. AWS Command Line Interface, CLI, a unified tool to manage your Oz services from the command line. It's powerful for scripting and automating common S3 tasks, allowing you to quickly perform operations like creating buckets, uploading files, or listing objects right from your terminal. AWS Software Development Kits, SDKs. These are libraries available in many popular programming languages, like Python, Java, JavaScript, Net, Go, and more, that allow your applications to interact with S3. The SDKs abstract away the complexities of the underlying S3 REST API, making it easy to integrate S3 into your code. This is how most applications interact with S3 Scale. For your very first interaction, let's conceptually walk through creating a bucket and uploading an object using the console or CLI without delving into specific syntax yet. Creating a bucket, conceptually, you would specify a unique name, e.g., my first dev, bucket 2023 Zeiss, and choose an AWS region, e.g., US East 1. S3 quickly provisions this container for you, uploading an object conceptually. You would then choose a file from your local machine, specify its target bucket and a key name, e.g., mydocument.txt or upload/mydocument.txt, and S3 would store it within the bucket. After upload, you could access it via unique URL. 1.4 Why developers love S3. S3's architectural elegance and powerful feature set make it an indispensable tool for developers. Building block for everything. S3 serves as the backbone for countless AWS services. CloudFront uses it for content distribution, Lambda functions are triggered by S3 events, Athena queries data directly from S3, and data lakes use S3 as their primary storage layer. Understanding S3 unlocks a vast ecosystem of cloud functionalities. Serverless friendliness. For developers embracing serverless architectures, S3 is a perfect fit. It's entirely managed by Oz, meaning you don't provision or manage servers. This aligns perfectly with the serverless philosophy of focusing solely on your application logic. Cost efficiency at scale. Its tiered pricing and diverse storage classes allow applications to scale from a few kilobytes to petabytes without prohibitive costs, making it accessible for startups and large enterprises alike. Low operational overhead. Since S3 is a fully managed service, AWS handles all the underlying infrastructure, maintenance, and scaling. Developers can focus on building features rather than managing storage servers. 1.5 What this book will cover. This book is structured to guide you from foundational knowledge to advanced S3 mastery. We'll progress through the following key areas. Chapter 2, S3 Fundamentals. A deeper dive into the properties of buckets and objects, and the crucial S3 storage classes for cost optimization. Chapter 3, Mastering S3 Security. Understanding IAM, bucket policies, and encryption to keep your data safe. Chapter 4, Data Management. How to use versioning, lifecycle rules, and replication for intelligent data lifecycle management. Chapter 5, Interacting with S3. A comprehensive look at using AWS SDKs and the AWS CLI for programmatic control. Chapter 6, Hosting Static Websites. A practical guide to deploying web applications directly on S3. Chapter 7, S3 for data storage. Leveraging S3 for backups, archives, and building robust data lakes. Chapter 8, Enhancing Performance and Reducing Costs. Strategies to optimize S3 for speed and efficiency. Chapter 9, Event-Driven Architectures. Building reactive applications using S3 event notifications and AWS Lambda. Chapter 10, Integrating S3 with other Oz services. Exploring powerful combinations with CloudFront, Athena, and more. Chapter 11, Advanced S3 Topics. Diving into complex features like S3 access points for granular access control. Chapter 12, Best Practices, Troubleshooting, and the Future. Consolidating knowledge, solving common problems, and looking ahead. By the end of this journey, you'll not only understand the what and how of Amazon S3, but also the why. Why it's the industry standard for cloud storage, and how you can harness its power to build the next generation of cloud applications. Chapter 2, S3 Fundamentals. Buckets, Objects, and Regions Explained. In Chapter 1, we establish the bedrock principles of Amazon S3, that it's an object storage service built around buckets, objects, and regions. Now, we'll peel back the layers on these core components, uncovering the details and nuances that developers need to truly master S3. Understanding these fundamentals deeply is key to designing resilient, cost-effective, and performant cloud applications. 2.1 Diving deeper into buckets. Buckets are more than just simple storage containers. They come with a rich set of properties and behaviors that influence how your data is stored, accessed, and managed. 2.1.1 Bucket naming, conventions and requirements. While seemingly minor, bucket naming is important for organization and global uniqueness. Here are the key rules. Uniqueness. As discussed, bucket names must be globally unique across all existing S3 bucket names in a given Oz partition, e.g., Oz, OzCN, OzGovCloud. If you try to create a bucket with a name already taken, S3 will reject the request. This is why you often see long, descriptive, or account-specific prefixes in bucket names, e.g., my company prod app logs us East1. Length. Names must be between 3 and 63 characters long. Characters. They can consist only of lowercase letters, numbers, and hyphens. Take note, uppercase letters, underscores, and periods are generally not allowed in new bucket names for compatibility with static website hosting and other features. Start and end. Names must start and end with a lowercase letter or number. Format. Names must not be formatted as an IP address, e.g., 192.168.1.1. Prefixes. Using standard prefixes like S3, Oz, Amazon is not permitted to avoid collisions with AWS services. Sensible naming conventions, e.g., Project Environment Data Type Region, are crucial for organization, especially as your AWS footprint grows. 2.1.2 Bucket versioning. While we'll dedicate a full section to versioning in Chapter 4, it's worth noting here that versioning is a bucket-level setting. When enabled, S3 retains multiple variations of an object in the same bucket. This provides a robust form of backup, protecting against unintentional deletions or overwrites. You can either enable or suspend versioning on a bucket. It's a critical feature for any application where data integrity and the ability to roll back changes are paramount. 2.1.3 Bucket policies versus IAM policies. Access control is a cornerstone of S3 security, and developers will encounter two primary mechanisms: bucket policies and IAM policies. While both are written in JSON and control permissions, their scope and typical use cases differ. Bucket policies. These policies are attached directly to an S3 bucket itself. They define who can access the objects within that specific bucket and what actions they can perform. Use bucket policies when you need to grant public access, allow cross-account access to a bucket, or enforce specific conditions on all access to a bucket. They primarily govern what happens at the bucket level. IAM policies, identity and access management. These policies are attached to AWS Identity and Access Management, IAM, identities, users, groups, or roles. They define what actions a particular identity can perform on various AWS resources, including S3 buckets and objects. Most programmatic access from applications or EC2 instances will use IAM roles and policies. IAM policies largely govern what an identity can do. Think of it this way: an IAM policy specifies what John can do across Oz. A bucket policy specifies what can be done to a specific MyReports bucket. For an action to be allowed, both policies must permit it, unless the action is publicly allowed by the bucket policy without explicit IAM permission. We will dive into these extensively in Chapter 3. 2.1.4 Bucket properties. Logging, tagging, and object lock. Brief introduction. Beyond versioning, buckets have several other configurable properties. Logging. You can enable server access logging for your bucket, which provides detailed records for every request made to S3. These logs themselves are stored as objects in another S3 bucket, making them ideal for security auditing, compliance, and analyzing usage patterns. Tagging. Just like other Oz resources, you can apply tags, key-value pairs, to your S3 buckets. Tags are incredibly useful for cost allocation, organization, and automation, e.g., tagging all production buckets with environment. Production for easier cost reporting. Object lock. Introduced in Chapter 4, S3 Object Lock provides write-once-read-many-worm capability, preventing objects from being deleted or overwritten for a fixed amount of time or indefinitely. This is a critical feature for regulatory compliance and data retention policies. 2.2 Understanding objects, your data's DNA. Objects are the actual data units in S3, each with its unique identity and properties. 2.2.1 Object keys, the name of your data. Every object in S3 has a key, which is its unique identifier within a bucket. The key is essentially the object's full path and name. For instance, if you upload photo.jpg to a bucket My Vacations, its key is simply photo.jpg. If you place it under a folder called Summer 2023, its key becomes Summer 2023 photo.jpg. Hierarchical illusion. As mentioned, S3 is a flat structure. The folders you see in the AWS Management Console, Summer 2023, are simply S3's way of interpreting the slashes in object keys. There are no actual directories on the underlying data store. This matters for performance, as S3 doesn't need to traverse directory trees. Best practices for keys, prefixing for parallelism. Historically, S3 had performance considerations around object prefixes, while modern S3 handles high request rates for any prefix, planning your key names to distribute write and read traffic across multiple prefixes. E.g., instead of logs 2023 to 1 to 1 to 2 to 0 0 log.txt, use logs user 1 2023, or logs 00 2023, can still be beneficial for extremely high-volume workloads and better partitioning. Human readability. Choose meaningful key names that describe the object's content. Consistency. Maintain a consistent naming convention across your objects. Character safety. Avoid special characters that might be problematic in URLs or different operating systems, e.g., and hash spaces. While S3 supports them, it can lead to encoding headaches. Using alphanumeric characters, hyphens, and slashes is safest. 2.2.2 Object metadata, describing your data. Metadata is data about your data. In S3, every object has metadata, which helps describe its content or purpose. System-defined metadata, S3 automatically adds metadata for you. Examples include etag, a hash of the object content, useful for checking if an object has changed. Content type, the MIME type of the file, e.g., image JPEG, text/HTML. This is crucial for web applications to display content correctly. Content length, the size of the object in bytes, last modified, the date and time the object was last modified. XAMPP storage class, the storage class used for the object. XAMPP's version ID, the unique version ID if versioning is enabled. User-defined metadata, you can associate your own custom metadata with an object when you upload it. These are simple key-value pairs that are stored directly with the object. They must always begin with XAMPP's meta, e.g., XAMPP's meta author, John Doe. Use cases, storing application-specific information, userid. 12,345 Process status, pending, tagging objects for internal classification department, marketing or indicating data origin, source system, CRM. Note that user-defined metadata maxes out at 2 KB total. 2.2.3 Object size and throughput considerations. S3 handles objects from 0 bytes up to 5 terabytes in a single upload operation. For objects larger than 5 gigabytes, you must use multi-part upload. This involves breaking the object into smaller parts, uploading them independently, and then telling S3 to combine them into a single object. Multi-part upload offers several benefits. Increased throughput. You can upload parts in parallel, significantly reducing the total upload time for large files. Resilience. If a part upload fails, you only need to retransmit that specific part, not the entire object. Pause and resume. You can pause an upload and resume it later by continuing to upload remaining parts. Developers frequently use multi-part uploads for large video files, big data archives, or large application binaries. SDKs often handle multi-part uploads automatically for files above a certain size threshold. 2.3 S3 storage classes, choosing the right fit for your data. One of S3's most powerful features for cost optimization is its variety of storage classes. Each class is designed for specific access patterns and offers different levels of availability, durability, and cost. Choosing the right storage class can dramatically reduce your S3 bill. Here's a breakdown of the primary S3 storage classes. S3 Standard High Performance Frequent Access Durability 99.9999999%, 11 nines. Availability 99.99%. Use cases: highly relational data, mobile and gaming applications, big data analytics, content for web applications, or data that requires frequent access. This is the default storage class. Cost: highest cost per GB of storage but lowest cost per request. S3 Intelligent Tiering Automated Cost Optimization. Durability 99.999999999%. Availability 99.9%. Use cases: data with unknown or changing access patterns. This class automatically moves data between two frequently accessed tiers, equivalent to S3 Standard, and two infrequently accessed tiers, equivalent to S3 Standard IA and S3 One Zone IA, based on usage, without performance impact or operational overhead. It also optionally offers an archive access tier, equivalent to S3 Glacier, and deep archive access tier, equivalent to S3 Glacier Deep Archive. Cost: storage costs vary depending on the tier an object is in. There's a small monitoring and automation charge per object. S3 Standard Infrequent Access, S3 Standard AA, Long-Lived Infrequent Access, Durability 99.9999999%. Availability 99.9%. Use cases: long-lived data that is infrequently accessed but requires quick retrieval when needed. Examples include backups, disaster recovery files, or older analytical data. Cost: lower storage cost than S3 Standard, but higher retrieval costs and a minimum storage duration, 30 days, and minimum billable object size, 128 KB. Designed for data accessed less than once a month. S3 One Zone Infrequent Access, S3 One Zone IA, Reconstructible Infrequent Access, Durability 99.9999999%. This durability is for the data within a single availability zone. Availability 99.5%. Use cases: primarily for storing easily reconstructible data, like secondary backups, or data that is not critical to store across multiple availability zones. If the availability zone where your data is stored becomes unavailable, you lose the data. Cost: lower storage cost than S3 Standard IA, similar retrieval costs, same minimum storage duration, 30 days, and billable object size, 128 KB. Lowest cost for infrequent access. S3 Glacier Archival, seldom accessed, durability 99.9999999%. Availability 99.99%. Use cases: long-term archival of data that is rarely accessed but can afford retrieval times ranging from minutes to hours. Examples include regulatory archives, medical records, or older media content. Cost: very low storage cost. Retrieval costs vary significantly based on retrieval speed, expedited, standard, bulk, and can take from a few minutes to several hours. Minimum storage duration of 90 days. S3 Glacier Deep Archive, lowest cost archival, rarely accessed. Durability 99.9999999%. Availability 99.99%. Use cases: the lowest cost storage option for long-term archival. Ideal for data accessed once or twice a year, if at all. Examples include historical records, broadcast footage, or scientific data sets with strict retention requirements. Cost: exceptionally low storage cost. Retrieval times are typically 12 to 48 hours. Minimum storage duration of 180 days. Choosing the right class for your application. As a developer, understanding these classes is crucial for building cost-efficient applications. Scenario 1. User-uploaded content. For an application allowing users to upload profile pictures or frequently accessed documents, S3 Standard is often the best choice due to its low latency and high throughput. Scenario 2. Analytics logs. If your application generates large volumes of logs that are initially accessed frequently for real-time monitoring, but then become less frequent for historical analysis, S3 intelligent tiering is excellent because it automates the cost savings. Scenario 3. Application backups. For daily or weekly backups of databases or application states that you might need to restore quickly but don't access regularly, S3 Standard IA offers a good balance of cost and retrieval speed. Scenario 4. Long-term financial records. For data that must be retained for years for compliance, like old financial transaction records, S3 Glacier or S3 Glacier Deep Archive would be the most economical choice. 2.4 Regions and Availability Zones, AZS, where your data lives. While we touched upon regions in Chapter 1, it's vital to grasp their underlying structure and implications for S3. Regions. An AWS region is an isolated and geographically separate area where AWS resources are hosted. Each region is designed to be completely independent, offering full fault isolation. This means that an issue in one region won't affect another. Availability zones, AZs. Within each AWS region, there are multiple, isolated locations called availability zones. An AZ consists of one or more discrete data centers, each with redundant power, networking, and connectivity, housed in separate facilities. AZs within a region are connected with low latency, high throughput, and redundant networking. How S3 leverages AZs for durability. When you store an object in S3 Standard, or other multi-AZ storage classes like Standard AA, Intelligent Tiering, Glacier, Deep Archive, S3 automatically replicates your data across a minimum of 3 availability zones within the chosen region. This is how S3 achieves its 11 nines of durability. If an entire availability zone becomes unavailable, a very rare event, your data remains accessible and unaffected because copies exist in other AZs. This high level of redundancy is managed entirely by Oz, removing the burden of replicating data yourself. Choosing the right region. The region you select for your S3 bucket has direct implications: geographic proximity and latency. For web applications, storing your S3 data in a region geographically closest to the majority of your users can significantly improve the user experience by reducing the time it takes to retrieve data. For backend applications, proximity to your compute resources, EC2, Lambda, is critical. Data residency and compliance. As mentioned, regulatory requirements often dictate where data must physically reside. This is a primary driver for choosing specific regions, e.g., EU GDPR requirements might necessitate EU West 1 or EU Central 1. Cost differences. While generally minor, some AWS services, including S3, have slightly different pricing models across regions due to infrastructure costs, local regulations, or market dynamics. Feature availability. Oz introduces new features and services at different rates across regions. While core S3 features are widely available, newer, specialized S3 capabilities or integrations with other AWS services might not be immediately available in all regions. 2.5 Practical example. Storing user-uploaded content with appropriate storage class. Let's put some of these concepts into a practical scenario. Imagine you're building a social media application where users upload photos and videos. Bucket creation. You'd likely create a bucket named something like My Social App User Media, US-West 2 in the US-West 2, Oregon region, assuming most of your users or application servers are in that geographical area. Object keys. When a user uploads a photo, you generate a unique key. For example, users/userid123/photos/imageapp.jpg. For videos, users/userid123/videos/videoxmp4. These keys naturally group content by user. Storage class for photos. For user photos, which are likely accessed frequently, S3 Standard is the default and best choice because of its low latency and high throughput. Storage class for videos and older content. Videos might be less frequently accessed once uploaded, or perhaps only premium users watch older content. You could initially store them in S3 Standard, but then implement a lifecycle rule, covered in Chapter 4, to transition video objects that haven't been accessed in 30 days to S3 Standard IA for cost savings. For very old, highly archived videos, you could transition them to S3 Glacier Deep Archive after, say, 180 days of inactivity. Metadata. When a photo is uploaded, you might add user-defined metadata indicating the user's ID, the device it was uploaded from, or original resolution. S3 automatically adds system metadata like content type, image JPEG. Versioning. You would almost certainly enable versioning on this bucket to protect against accidental deletion or overwriting of user media. If a user accidentally deletes a photo, you can restore a previous version. This example highlights how a developer makes deliberate choices about bucket naming, object key structure, and storage classes to optimize an application for performance, cost, and data integrity. Conclusion of Chapter 2. By now, you should have a solid grasp of S3's core components and why each design choice matters. Buckets are your unique containers configured for specific behaviors. Objects are your data, uniquely named and enriched with metadata. And regions dictate where your data physically resides, influencing latency, compliance, and cost. Most importantly, the diverse range of S3 storage classes provides powerful levers for optimizing storage costs based on access patterns. With these fundamentals in place, we can now move to the paramount topic for any developer working with cloud storage. Security. Chapter 3. Mastering S3 Security, IAM, Bucket Policies, and Encryption. When dealing with data, especially in the cloud, security is not just a feature. It's a fundamental requirement. Amazon S3, being a central repository for vast amounts of data, offers a comprehensive suite of security features to protect your information. As a developer, understanding how to properly configure these controls is paramount. A single misconfiguration can expose sensitive data, leading to breaches, reputational damage, and significant compliance issues. This chapter will equip you with the knowledge to safeguard your S3 data using IAM, bucket policies, and various encryption methods. 3.1. The Shared Responsibility Model. Your role in S3 security. Before diving into specific features, it's critical to understand the AWS Shared Responsibility Model. This model clarifies what Oz is responsible for and what you are responsible for when using their cloud services. AWS Responsibility. Security of the cloud. Oz is responsible for protecting the infrastructure that runs all the services offered in the AWS cloud. This security of the cloud includes the physical security of the data centers, the underlying network infrastructure, the virtualization layer, and the hardware that hosts S3. Oz ensures the durability and availability of the S3 service itself. Your responsibility. Security in the cloud. As a user, you are responsible for security in the cloud. For S3, this means your responsibility includes data security, configuring access controls, IAM, bucket policies, encrypting your data at rest and in transit, data management, managing your objects, versioning and lifecycle policies, network configuration, ensuring your security groups, network ACLS and VPC settings, if applicable, restrict access appropriately. Audit and logging, monitoring access and usage of your S3 buckets. Essentially, AWS provides the secure building, but you are responsible for locking its doors, encrypting its contents, deciding who has the keys, and monitoring who comes and goes. Neglecting your share of this responsibility is the most common cause of cloud security incidents. 3.2. Identity and Access Management, IAM for S3. IAM is the cornerstone of access control in AWS, including S3. It allows you to securely control who or what can access your AWS resources and what actions they can perform. 3.2.1 IAM Entities, Users, Roles, and Groups. IAM users represent a person or service that interacts with Oz. For most applications, especially those running on AWS compute services, you should avoid creating IAM users with long-lived credentials. IAM roles. The preferred way for applications, e.g., running on EC2 instances, AWS Lambda functions, or container services, to access Oz resources. A role is an identity that you can assume, granting temporary permissions. This avoids embedding static credentials directly into your application code, significantly improving security. IAM groups, a collection of IAM users. You can attach an IAM policy to a group, and all users in that group inherit those permissions. 3.2.2 IAM policies, defining permissions. An IAM policy is a JSON document that defines permissions. When attached to an IAM identity, user, role, or group, it grants or denies specific permissions on Oz resources. For S3, an IAM policy typically specifies effect, whether the policy allows or denies access. Action, the specific S3 API operations that are allowed or denied. For example, S3 getObject to download an object, S3, putObject to upload an object, S3, listBucket to list objects within a bucket. There are hundreds of S3 actions. Resource, the S3 bucket or object to which the actions apply, specified by its Amazon resource name, ARN. An ARN for a bucket looks like ARN Oz S3, myExample bucket, and for objects, it's ARN Oz S3, myExample bucket / where denotes all objects within the bucket. Condition, optional. Criteria that must be met for the policy to take effect, e.g., requiring a specific IP address, multi-factor authentication, or particular object metadata. Principle of least privilege. A fundamental security best practice is the principle of least privilege. This means granting only the minimum permissions required for a user or application to perform its intended function. For example, if your application only needs to read objects from a bucket, grant it S3, getObject and perhaps S3, listBucket but not S3, putObject or S3, deleteObject. Following this principle reduces the attack surface and limits the impact of compromised credentials. Conceptual IAM policy example. Imagine an application running on an EC2 instance that needs to read user-uploaded images from a bucket called myAppUserImages. You would create an IAM role for the EC2 instance and attach a policy to it that conceptually looks like this. Allow the role to S3, getObject on objects within ARN Oz S3, myAppUserImages / and to S3, listBucket on ARN Oz S3, myAppUserImages. This policy explicitly permits downloading files and listing the contents of that specific bucket, but nothing else. 3.3 Bucket policies, granting programmable access. Bucket policies are JSON policies directly attached to an S3 bucket. They are primarily used to define permissions for principals, users, or roles that are not in your Oz account, or to grant broad access permissions that are difficult to manage with IAM policies alone. They are evaluated alongside IAM policies. If either an IAM policy or a bucket policy explicitly denies an action, it is denied. If neither denies and at least one allows, it is allowed. When to use bucket policies. Public access, making a bucket or specific objects within it publicly readable, e.g., for static website hosting. Cross-account access, granting another Oz account or specific IAM users' roles in another account access to your bucket. This is common for sharing data with partners or centralizing logs from multiple accounts. Force encryption, specific headers, enforcing that all uploads to a bucket must use a specific encryption type or include certain headers. Access from specific IP ranges, restricting access to a bucket from only a defined set of IP addresses. Conceptual bucket policy example, public read access for a static website. If you were hosting a static website on S3, your bucket policy might conceptually state, allow anyone, the principal, to S3, getObject on all objects within ARN Oz S3, your static website bucket /. This explicitly opens the door for anyone on the internet to read those objects. This is why public bucket policies must be used with extreme caution. 3.4 Access Control Lists, ACLS, legacy but still relevant. Older than IAM and bucket policies, access control lists, ACLS, provide a more granular, object-level way to manage permissions. An ACL is attached to an individual object or bucket and defines who can perform specific actions, like read, write on that resource. When to use ACLS, legacy applications, older applications might still rely on ACLs. Specific S3 features. Certain S3 functionalities, like S3 server access logging, require predefined ACLs to allow the logging service to write logs to your bucket. Very specific cross-account uploads. Though less common now, ACLs can be used when another account uploads an object to your bucket and wants to retain ownership or grant specific permissions back to the original owner. Why bucket policies are preferred? For most general-purpose access control, bucket policies, for bucket-wide rules, and IAM policies, for user role-based rules, are more powerful, flexible, and easier to manage than ACLs, especially at scale. Oz itself recommends using IAM and bucket policies over ACLs for most use cases. 3.5 Data encryption in S3. Protecting your data at rest and in transit. Beyond access control, encryption is a crucial layer of defense for your S3 data. 3.5.1 Encryption in transit, SSL/TLS. All data transfers to and from S3 should be encrypted using Secure Sockets Layer, SSL, or Transport Layer Security, TLS. This protects your data from eavesdropping as it travels across the internet. By default, all S3 endpoints support HTTPS, and you should always enforce it in your application code and configurations. For example, when fetching an object using an SDK, you'll implicitly use HTTPS unless you explicitly configure otherwise, which is highly discouraged. 3.5.2 Encryption at rest. Securing data when stored. S3 offers several options for encrypting your data when it's stored on disk. So even if unauthorized access to the storage hardware occurs, the data remains unreadable. Server-side encryption with S3 managed keys, SSE S3. How it works. S3 handles the encryption and decryption using Amazon S3 managed encryption keys. Each object is encrypted with a unique key, which is itself encrypted with a master key rotating regularly. You don't need to do anything with keys, S3 manages it all transparently. Developer impact, minimal. You simply set a header in your upload request, e.g., XAM server-side encryption, IS 256. S3 handles the rest. Use case. The easiest and most common way to ensure data at rest is encrypted. Server-side encryption with KMS managed keys, SSE KMS. How it works. S3 encryption is managed by AWS Key Management Service, KMS, giving you more control over the encryption keys. You can use an AWS managed key, a default key in your account for KMS-enabled services, or create your own customer-managed keys, CMKS. CMKs allow you to set policies on key usage, rotate keys automatically, and audit key access through AWS CloudTrail. Developer impact. Your application needs IAM permissions to use the specified KMS key for encryption and decryption. You'll specify the KMS key ID in your upload requests. Use case. When you need a centralized key management service, more granular control over key usage permissions, or auditing of key usage. Required for S3 object lock in compliance mode. Server-side encryption with customer-provided keys, SSEC. How it works. You provide your own encryption key to S3 as part of the request. S3 encrypts the object with that key, then discards the key after encryption. To retrieve the object, you must provide the same key again to S3 for decryption. S3 handles the encryption process, but you manage and store the key outside of Oz. Developer impact. Your application must securely store and manage the encryption key. It must send the key, hashed with every upload and download request. Use case. When you have strict organizational security policies that mandate full control over encryption keys and prevent them from being stored by any cloud provider, even KMS. This is more complex to manage securely. Client-side encryption. How it works. You encrypt the data using your own encryption library before sending it to S3. S3 receives an already encrypted object and stores it as is. You are entirely responsible for the encryption, decryption, and key management. Developer impact. Significant. You integrate a cryptographic library into your application and handle all key storage and management. Use case. When you have absolute data sovereignty requirements and want full end-to-end control over the encryption process, ensuring your unencrypted data never touches Oz servers. This offers the strongest security in the cloud, but comes with the highest management overhead. Default encryption for S3 buckets. Oz now encourages setting default encryption on S3 buckets. This ensures that all new objects uploaded to a bucket are automatically encrypted with SSE S3 or SSE KMS, even if the upload request doesn't explicitly specify encryption. This provides an important guardrail against accidentally uploading unencrypted data. 3.6 Public access blocks, preventing accidental exposure. One of the most effective security features introduced by S3 is public access block. This setting, configured at the account level or per bucket, provides strong safeguards to prevent accidental public exposure of your S3 data. Even if you explicitly configure a bucket policy to allow public access, a public access block setting can override it and deny that access. Public access block configurations include options to block public access to buckets and objects granted through any access control list, ACL, prevents individual object ACLs from making data public. Block public access to buckets and objects granted through new public bucket or access point policies, prevents newly created public policies from taking effect. Block public and cross-account access to buckets and objects through any public bucket or access point policies, affects existing public policies as well. Block public access to buckets that have an any user access policy specified in their bucket or access point policies, prevents granting public access. Best practice. For most private, sensitive, or internal-facing applications, it's highly recommended to enable all 4 public access block settings at the account level. This acts as a powerful safety net, ensuring no S3 bucket within your account can inadvertently become publicly accessible. If you truly need public access, e.g., for a static website, you would selectively disable specific block settings on only that one bucket, while keeping the account-level blocks active as a default. 3.7 Security best practices for developers. Beyond the specific features, adopting a security-first mindset is crucial. Least privilege. Always grant only the minimum permissions necessary. Regularly review and audit your IAM policies and bucket policies. Use IAM roles for applications. Never hardcode Oz access keys directly into your application code. Use IAM roles for EC2 instances, Lambda functions, and other compute services. Oz handles the secure delivery of temporary credentials to these resources. Encrypt data by default. Enable default encryption on your S3 buckets. Choose SSE S3 for simplicity or SSE KMS for greater control over keys. Protect in-transit data. Always use HTTPS. HTTPS my-bucket.s3.oz-region.amazonos.com when accessing S3 endpoints. Enable public access blocks. As mentioned, apply these broadly as a primary defense. Enable server access logging and CloudTrail. Log all access attempts and API activities. These logs are vital for security audits, forensics, and detecting anomalous behavior. S3 server access logs. Record detailed information about requests made to your S3 buckets, who accessed what, when, from where. AWS CloudTrail. Records all API calls made to S3 and other Oz services as events. This provides a comprehensive audit trail of management and data plane operations. Regular security audits. Periodically review your S3 configurations, bucket policies, and IAM policies, especially for buckets containing sensitive information. Automated tools like AWS Config or third-party security scanners can help. Validate user input. If your application receives user-uploaded data, always sanitize and validate it to prevent malicious content from being stored or executed. Vulnerability scanning. Regularly scan your application code and infrastructure for known vulnerabilities that could expose S3 data. Case study. Securing a media library stored in S3. Consider a media company storing millions of video and audio files in S3. Their security posture would likely involve account-level public access blocks, enabled by default to prevent accidental exposure of core media assets. Dedicated S3 buckets, separate buckets for raw uploads, processed media, and public distribution. Default encryption, All raw media buckets automatically encrypt uploads using SSCKMS for stronger key management and auditing, with a customer-managed key. Strict IAM roles, upload service role, an IAM role for the service that handles user uploads with S3, put object permission restricted to specific prefixes, raw uploads. Processing service role, an IAM role for the video transcoding service, with S3 getObject on raw uploads and S3 putObject on processed media playback service role, an IAM role for the media streaming service, with S3 getObject restricted to processed media and S3 list bucket on relevant prefixes. Private CloudFront distribution. For all public media delivery, CloudFront is used with an Origin Access Control, OAC, to ensure that users access content only asterisk through CloudFront and never directly from the S3 bucket itself. The S3 bucket policy explicitly allows access only from the CloudFront distribution's OAC. Server access logging. All S3 buckets have server access logging enabled, with logs directed to a separate, highly secured, audit-only bucket in a different account. S3 object lock for archival. For compliant long-term archival of original raw footage, a separate bucket uses S3 object lock in compliance mode, ensuring immutable storage. This multi-layered approach uses a combination of S3's native security features and broader OZ security practices to protect valuable media assets throughout their lifecycle. Conclusion of Chapter 3. Security is not a checkbox. It's an ongoing process and a critical shared responsibility. By diligently applying the principles of least privilege, leveraging IAM roles, understanding the nuances of bucket policies, and implementing appropriate encryption strategies, developers can ensure their data in Amazon S3 is robustly protected. Move forward with the confidence that you are employing the industry's leading practices to build secure, reliable cloud applications. Next, we'll explore how S3 helps you manage your data dynamically through its powerful versioning, lifecycle, and replication capabilities. Chapter 4, Data Management with S3. Versioning, lifecycle rules, and replication. Amazon S3 isn't just about storing data. It's about intelligently managing it throughout its lifecycle. As applications grow, data accumulates rapidly, and diverse needs emerge. Protecting against accidental changes, optimizing storage costs over time, ensuring business continuity, or meeting compliance requirements. S3 provides a suite of powerful features, versioning, lifecycle rules, and replication that allow developers to automate these complex data management tasks, ensuring your data is resilient, cost-effective, and always where it needs to be. 4.1 Versioning. Protecting against accidental deletes and overwrites. Imagine accidentally deleting a critical configuration file or overwriting a user's uploaded document. Without a safety net, such mistakes could be catastrophic. S3 versioning offers that safety net, preserving every version of an object in a bucket. How versioning works. When you enable versioning on an S3 bucket, S3 automatically assigns a unique version ID to every new object uploaded to that bucket. If you then upload a new file with the same key name as an existing object, S3 doesn't overwrite the old object. Instead, it stores the new file as a new version, assigning it a new unique version ID, and the previous version remains preserved. The most recently uploaded version becomes the current version by default. If you delete an object from a version bucket, S3 doesn't permanently remove it. Instead, it adds a delete marker as the current version. This delete marker makes the object appear deleted, but the previous versions of the object, before the delete marker was applied, are still safely stored and can be restored. To permanently delete an object, you must delete all of its versions, including delete markers, typically by specifying their version ID's benefits of versioning. Data recovery. Easily recover from unintended user actions, e.g., accidental deletion, application failures, or even malicious attacks like ransomware. Data audit. Maintain a history of all changes to an object, which can be crucial for auditing and compliance. Rollbacks. Revert to an earlier state of an object if a new version introduces errors or stability issues. Cost implications. Versioning comes with a cost. Each object version is a separate object, so you are billed for the storage of all versions. This is an important consideration, especially for frequently updated objects. However, lifecycle rules can help manage this cost. See next section. Suspending versus disabling versioning. You can suspend versioning on a bucket. When suspended, new objects uploaded with existing keys will overwrite the original object, with no new versions created, but all existing versions remain. You cannot disable versioning once enabled, only suspend it. This prevents accidental loss of previous versions. Use cases: storing user-generated content, photos, documents, retaining historical application configuration files, keeping multiple versions of machine learning models for reproducibility. 4.2 S3 Lifecycle Management Rules. Automating data transitions and expiration. As data ages, its access patterns often change. Frequently accessed initially, less so later, and eventually archived or deleted. Manually moving or deleting vast amounts of data is inefficient and error-prone. S3 Lifecycle Management Rules automate these processes, helping you optimize costs and manage data retention policies. Lifecycle rules have two main actions: transition actions. Move objects from one storage class to another after a specified period. This is how you shift data from more expensive, frequently accessed tiers to less expensive, infrequent access or archival tiers. Example: imagine a large collection of photos. You might set a rule to move them from S3 Standard to S3 Standard IA after 30 days for cost savings, as they're less actively viewed. Then, after another 90 days, you might transition them to S3 Glacier for long-term, very low-cost retention. Expiration actions. Permanently delete objects or specific versions of objects after a specified period. Example: for temporary user uploads, you might set a rule to delete current versions of objects after 7 days automatically. If versioning is enabled, you might configure a separate rule to delete non-current, older versions after 30 days to control versioning storage costs. Rule filters. You can apply lifecycle rules to entire buckets or filter them based on prefix. Apply the rule only to objects whose keys start with a specific string, e.g., logs, temp uploads / object tags. Apply the rule only to objects that have specific key value tags, e.g., objects tagged project, archival. Object size. Apply the rule to objects within a specific size range. Benefits of lifecycle rules: cost savings. Automatically move data to the most cost-effective storage class as its access frequency changes. Automated data retention. Ensure compliance by automatically deleting data that no longer needs to be retained, or conversely, ensuring data is kept for a minimum required period. Operational efficiency. Eliminates manual data management tasks, freeing up developer time. Common scenarios for developers: log management. Transition application logs to S3 Standard IA after a week, then to Glacier after a month, and finally expire them after a year. Temporary uploads. Automatically delete temporary files or user uploads that were never fully processed after 24 hours. Old backups. Archive older database backups to Glacier Deep Archive and eventually expire them after several years. Managing non-current versions. If versioning is enabled, set a rule to expire non-current versions after a certain number of days or after keeping a specific number of non-current versions to control versioning costs. 4.3 Cross-region replication, CRR, and same-region replication, SRR. Replication in S3 allows you to automatically and asynchronously copy objects between S3 buckets. This is a powerful feature for disaster recovery, compliance, and improving data access for globally distributed applications. Replication prerequisites. Both source and destination buckets must have versioning enabled. This ensures that S3 can track and replicate all object changes, including new versions, delete markers, and metadata updates. Appropriate IAM, identity and access management, permissions must be configured to allow S3 to replicate objects on your behalf. This is typically done through an IAM role that the S3 service assumes. Cross-region replication, CRR, purpose, replicates objects between buckets in different OS regions. Use cases, disaster recovery. a critical strategy for business continuity. If your primary region experiences a widespread outage, your data is already replicated to another region, allowing for faster recovery. Reduced latency. Serve content to geographically dispersed users from a bucket closer to them. For example, a media company could upload video assets to a bucket in the US, and CRR could push copies to buckets in Europe and Asia, resulting in faster streaming for customers on those continents. Compliance. Maintain object copies in different geographic regions to meet specific data residency requirements. Same region replication, SRR. Purpose. Replicates objects between buckets within the same AWS region. Use cases. Log aggregation. Replicate logs from multiple application buckets into a single, centralized data analytics bucket for easier processing and analysis. Live replication of production and test accounts. Replicate data from a production bucket in one account to a development or test account in the same region for immediate use in testing, without waiting for batch processes. This ensures test environments closely mirror production data without manual synchronizations. Compliance for data sovereignty. In some cases, organizations might need to store data in physically distinct accounts or buckets within the same region for specific compliance reasons, even if it's not for disaster recovery. How replication works. When an object is uploaded to the source bucket, S3 transparently replicates it to the destination bucket. Replication can be configured to replicate all objects or only objects that match certain prefixes or tags. For instance, you could configure a rule to replicate only objects under the public prefix or only objects tagged replicate, true. Object ACLS and object tags can also be replicated. Delete markers can be replicated, meaning a delete in the source bucket will also delete the object in the destination bucket by adding a delete marker. Or you can choose not to replicate delete markers to preserve data in the destination. Replication considerations. Existing objects. Replication rules apply to new objects uploaded after the rule is configured. To replicate existing objects that were present before the rule was set up, you'll need to use a separate AWS S3 batch replication job discussed later in this chapter. Costs. You pay for storage in both the source and destination buckets, and for data transfer costs for replication, as well as replication requests. Bidirectional replication. While technically possible to set up two replication rules, one from bucket A to bucket B and another from bucket B to bucket A, this can lead to complex and unintended consequences, like replication loops, and is generally not recommended as a primary strategy. For active-active multi-region setups, other services like AWS Global Accelerator might be more appropriate on top of CRR. 4.4 S3 Object Lock. Immutable storage for compliance. S3 Object Lock provides a write-once-read-many worm capability, helping you prevent objects from being deleted or overwritten for a fixed period or indefinitely. This is invaluable for regulatory compliance, e.g., SEC Rule 17a4, F, FINRA, HIPAA, and for ensuring data integrity against accidental or malicious deletion. Retention modes. Governance mode. Users with special permissions, those with S3, bypass governance retention permission, can typically override or shorten retention settings. This provides a balance between immutability and administrative flexibility. It's like having a secure vault, but with a master key for authorized users. Compliance mode. No user, including the root account, can delete or modify objects or alter the retention period until the retention period expires. This mode offers the highest level of protection and is ideal for highly sensitive regulatory requirements. Once set, it cannot be undone. It's like throwing away the master key after locking the vault. Legal holds. S3 Object Lock also supports legal holds. A legal hold prevents an object from being deleted or overwritten without using a retention period. You can place or remove a legal hold. This is useful for legal discovery or internal investigations where retention periods might be uncertain, and the hold needs to persist until a specific event occurs, not just a time duration. Legal holds override any retention period settings. How to enable and use. Object lock can only be enabled when you create a new S3 bucket. You cannot enable it on an existing bucket unless it is empty. This is a critical design choice to prevent accidental immutability on already populated buckets. Once enabled, you can apply retention periods to individual objects or use default retention periods on the bucket itself. Both governance and compliance modes can be applied at the bucket level as a default setting, and you can override these on a per-object basis. Use cases for developers: financial records. Store immutable copies of transaction logs, audit trails, and financial statements for regulatory compliance. Healthcare industry. Secure patient records or diagnostic images where data integrity must be guaranteed for many years. Digital preservation. Ensure the long-term integrity of historical archives, research data, or media assets. Ransomware protection. A strong defense against ransomware attacks, ensuring that even if systems are compromised, the original data in S3 cannot be encrypted or deleted by the attacker. 4.5 S3 batch operations. Managing many objects at once. While the previously discussed features automate ongoing data management, like new uploads or objects aging, sometimes you need to perform actions on a large number of existing objects that don't fit into a continuous rule. That's where S3 batch operations comes in. It's an incredibly useful tool for developers who need to perform large-scale, automated operations on vast numbers of S3 objects. It allows you to operate on billions of objects with a single request. How it works: you provide S3 batch operations with a manifest, a list of objects you want to operate on. This is typically a CSV file containing object keys, often generated by an S3 inventory report, which can list all objects in a bucket. You then specify an operation to perform on these objects. S3 batch operations supports copying objects to another S3 location, setting tags, adding, removing, or replacing object tags, changing access control lists, ACLS, updating object permissions, restoring objects from Glacier, initiating retrieval jobs for archived data, replacing all object metadata, updating all custom metadata, invoking an Oz Lambda function, running custom code for each object, deleting objects, bulk deletion of specific objects. S3 batch operations then manages the execution of this job, providing progress reports, completion reports, and detailed error information for any failed operations. Use cases: migrating storage classes, changing the storage class of millions of existing objects, e.g., from standard to standard IA if an access pattern changes across your entire dataset. Bulk tagging. Applying or removing tags from a large collection of objects for cost allocation or organization, especially after a new tagging convention is introduced. Data transformation. Invoking a Lambda function to process every object in a bucket, e.g., re-encrypting with a new KMS key, adding a watermark to images, converting file formats, extracting metadata. Backfilling replication. If you enable replication on a bucket, it only applies to new objects. Use batch operations to replicate all existing objects that were present before replication was configured. Expiring old data. Performing a one-time bulk deletion of data based on specific criteria that might not be easily captured by lifecycle rules. Practical application. Managing document versions and archiving older ones automatically. Let's revisit our social media application from Chapter 2, but this time, users can upload and modify documents. Versioning enabled. On the My Social App User Documents bucket, you would enable S3 versioning. This ensures that every time a user saves a new version of their document, the previous version is preserved. If a user accidentally deletes their document, you can immediately recover it to its previous state. Lifecycle rule for non-current versions. To control costs from retaining too many old versions, you might set a lifecycle rule. For example, transition non-current versions to S3 OneZone IA after 30 days, as they are less likely to be immediately needed for recovery and can be reconstructed if the AZ fails, and then delete non-current versions entirely after 90 days. This policy balances recovery needs with cost considerations. The currently active version stays in S3 standard, older versions get cheaper, and very old ones are purged. Lifecycle rule for current versions. For current versions of documents that haven't been accessed in a very long time, e.g., 2 years, you might transition them to S3 Glacier or S3 Glacier Deep Archive to save significant costs, assuming quick retrieval isn't necessary for such old documents. CRR for disaster recovery. If your application is critical and georedundancy is paramount, you might configure cross-region replication from My Social App User Documents Us West 2 to My Social App User Documents Us East 1. This means all new document uploads are automatically mirrored to a bucket in a different AWS region, providing robust disaster recovery capabilities. Object lock for sensitive documents. For certain categories of documents, e.g., legal agreements, compliance reports, uploaded to a separate, dedicated My Social App Legal Documents bucket, you might enable S3 Object Lock in compliance mode with a 7-year retention period and potentially add legal holds during ongoing litigation. This guarantees these specific documents cannot be altered or deleted for the required duration, even by powerful administrators, ensuring regulatory adherence. S3 Batch operations for historical cleanup. Imagine you had 50 million old temp files in a bucket that were not subject to lifecycle rules during a testing phase. Instead of manually deleting them or running a custom script on a compute server, you could generate an S3 inventory report, use its output as a manifest for S3 batch operations, and trigger a bulk delete job. This approach is highly scalable and reliable for one-off mass operations. Conclusion of Chapter 4. S3's data management features transform it from a simple storage service into a dynamic, intelligent system for data lifecycle automation. Versioning provides a safety net against data loss. Lifecycle rules are powerful financial and operational tools for optimizing costs and managing retention. Replication ensures data availability and compliance across regions or accounts. Object lock secures data immutably for the most stringent regulatory needs. Finally, S3 batch operations provides the muscle to perform large-scale, targeted actions on your data. As a developer, integrating these features into your application's data strategy will lead to more robust, cost-effective, and compliant solutions. In the next chapter, we'll shift our focus to how developers programmatically interact with S3 using AWS SDKs and the AWS command line interface. Chapter 5, Interacting with S3, the AWS SDKs and APIs for developers. While the AWS Management Console provides an excellent visual interface for S3, and the AWS command line interface, CLI, is invaluable for scripting quick tasks, the true power of S3 for application development comes from programmatic interaction. Developers use AWS Software Development Kits, SDKs, and the underlying S3 REST API to build applications that can seamlessly store, retrieve, and manage data at scale. This chapter explores how to interact with S3 programmatically, demonstrating the core operations and essential concepts for building robust S3 integrated applications. 5.1 The Power of Programmatic Access. For any application that needs to read or write data to S3 dynamically, programmatic access is essential. Here's why it's so powerful for developers. Automation. Automate repetitive tasks like uploads, downloads, or deletions based on application logic or events. For instance, an image processing service can automatically download a new image from S3, apply a filter, and upload the processed version back. Integration. Seamlessly integrate S3 into your application's workflow, whether it's a backend service, a mobile app, or a web frontend. S3 becomes a connected component in your software architecture. Scalability. Design applications that can handle high volumes of S3 operations concurrently, adapting to varying loads without manual intervention. Custom logic. Implement complex data processing, transformation, and storage patterns tailored to your specific use cases, such as custom data validation before storage or generating unique object keys for every upload. 5.2 Oz CLI, your command line companion. The AWS command line interface, CLI, is a unified tool for managing AWS services from your terminal. It's built on top of the Oz SDKs and provides a convenient way to perform S3 operations without writing a single line of application code. For developers, it's perfect for quick tests and debugging, rapidly verify bucket contents, inspect object metadata, or test permissions for a bucket policy you just changed. Scripting administrative tasks. Automate recurring operations like daily backups of a local database to S3, syncing local development files to a remote bucket, or cleaning up old test data. Initial setup. Easily create buckets, configure bucket policies, or enable features like versioning before integrating them into a larger application. Conceptual CLI operations. Imagine you want to create a bucket. You would use a CLI command specifying a unique bucket name and the AWS region where it should be created. Upload a file. You would use a command providing the local source file path and the destination S3 path, which includes the bucket name and the desired object name, key. Download a file. You would specify the S3 object's location, bucket, and key, and a local file path where you want to save it. List bucket contents. A command would efficiently show you the objects within a specified bucket, potentially filtered by prefix. Copy an object. A command would let you copy an object from one S3 location to another, even across different buckets. These commands make it easy to interact with S3 in a hands-on manner and can be chained together in shell scripts for more complex, automated workflows. 5.3 Oz SDKs. Building applications in your preferred language. Oz provides software development kits, SDKs, for a wide range of popular programming languages, including Python, Boto 3, Java, JavaScript for Node.js and browsers, Net, Go, Ruby, PHP, and more. SDKs simplify interactions with AWS services by handling many underlying complexities. Handling authentication. Securely manages your Oz credentials, providing different methods to authenticate your application to AWS. Abstracting API calls. You call well-named functions, e.g., putObject, getObject, instead of needing to understand the intricate details of crafting raw HTTP requests. Managing retries and error handling. Automatically retries requests that fail due to transient network issues or service throttling, making your applications more resilient. Serialization/deserialization. Handles converting your programming language's data structures to and from the formats, like JSON or XML, expected by the S3 API. Performance optimizations. Often include built-in features like connection pooling and multi-part upload logic to improve throughput. 5.3.1 Key SDK concepts. Before diving into operations, understand these core concepts common across SDKs. Client service objects. To interact with S3, you first create a client or service object for S3 within your chosen SDK. This client is the primary interface through which you'll make all your S3 API calls. It exposes all the S3 operations as methods. Conceptual example. In a Python application, you might import the Boto 3 library and then create an S3 client object. This object then has methods like upload file, download file, and list objects. Requests. When you call a method on the S3 client, e.g., to upload a file, you provide arguments or a request object that contains all the necessary parameters, such as the target bucket name, the desired object key, the file content, and any metadata you want to associate. Responses. S3 returns a response object or structure, which indicates whether the operation was successful. For successful operations, it contains any return data, e.g., the downloaded object's content, its eTag, a version ID, or a list of objects. Error handling. It's crucial to handle potential errors, e.g., bucket not found, access denied, no such key. SDKs typically throw specific exceptions or return error codes that you should catch and respond to gracefully within your application logic. 5.3.2 Common S3 operations via SDKs conceptual. Let's illustrate the basic logic for common S3 operations, without specific language syntax, to highlight the shared patterns developers will utilize. Listing buckets. Logic. Your application would invoke a method on the S3 client to list all buckets. Result. The response would contain a collection of bucket details, including their names and creation dates, allowing your application to enumerate available storage containers. Uploading objects, e.g. putObject. Logic. Call a method designed for object uploads, providing the data to be stored. You would specify the bucket name, the key, which is the full name, including any folder prefixes for the object in S3, and the body, the actual binary data of the file. Optional parameters might include the content type, e.g., image JPEG, various headers, or details for server-side encryption. Example scenario. A user uploads their profile picture via your web application. Your application's backend receives this image data. It then uses the S3 client method to upload this image to a designated S3 bucket, perhaps named user profiles, with a key like user12345profile.jpg. Multi-part uploads for large files. For objects larger than 100 megabytes, the exact threshold can be configured, or SDKs often handle it automatically. Best practice is to use multi-part upload. This process involves initiating a multi-part upload operation, which results in a unique upload identifier. Dividing the data into smaller parts, e.g., 5 MB chunks, and uploading each part individually, along with its part number and the upload identifier. These part uploads can be parallelized for speed. After all parts are successfully uploaded, completing the multi-part upload by providing the upload identifier and a list of all successfully uploaded part details. S3 then reconstructs the full object from these parts. This dramatically improves reliability and speed for transferring large files. Downloading objects, e.g. getObject. Logic. Invoke a method to retrieve an object, specifying the bucket name and the key of the object you wish to download. Result. The response will contain the object's body, the raw file content, along with its metadata, like content type, content length, and any custom metadata you added. Your application can then process or save this data. Example scenario. Your application needs to display a user's previously uploaded image. It fetches the image data from S3 using its key, then makes that data available to the front end for display. Deleting objects, e.g. deleteObject. Logic. Call a method for object deletion, providing the bucket and key of the object. Impact. If versioning is enabled on the bucket, as discussed in Chapter 4, this operation typically doesn't permanently delete the object, but rather places a delete marker as the current version. This makes the object appear deleted, but previous versions remain recoverable. To permanently delete a specific version, you would typically need to specify its versioned in the deletion request. Managing object metadata. Logic. S3 doesn't have a direct update metadata call for an existing object. Instead, to change an object's metadata, like content type or user-defined exams meta values, you effectively perform a copy object operation. You copy the object over itself, but specify new metadata in the copy request. The original and copied objects must be in the same location for this to work. 5.3.3 Presigned URLs. Secure temporary access to objects. Presigned URLs are a powerful security feature, commonly used by developers to grant temporary, time-limited access to objects in your S3 buckets. They allow access without making the bucket or objects publicly accessible and without requiring the user to have OAuth credentials. How they work. Your backend application, which operates with appropriate OAuth credentials, e.g., via an IAM role, generates a special URL for an S3 object. This URL contains a signature and an expiration timestamp. Anyone who possesses this URL can then perform a specific action, like downloading an object or uploading a file, to the S3 object until the URL expires. Use cases, direct uploads from client-side. A mobile app or web frontend can receive a presigned URL from your backend. It then uses this URL to upload a file directly to S3. This pattern offloads large file transfers from your backend servers, reducing their load and improving overall performance for client applications. Temporary downloads. Allow users to download private or sensitive content, e.g., a software installer, a financial statement, a private video, for a limited time after a successful login or payment. Sharing private content. grant temporary access to specific individuals or external systems for review or collaboration without making the data broadly public. Conceptual Presigned URL Flow. A user's web browser or mobile app wants to upload a large file to S3. The browser app sends a small request to your backend application, e.g., to an API endpoint. Your backend application, using an Oz SDK and its own IAM permissions, generates a presigned URL. This URL is tailored for a specific S3 PuteObject operation, targeting a particular bucket and object key, and includes an expiration time, e.g., 5 minutes, 1 hour. Your backend returns this generated presigned URL to the browser app. The browser app then uses this presigned URL to directly upload the file to S3. It does not need any Oz credentials of its own. The presigned URL automatically expires after its set duration, preventing further unauthorized use. 5.4 REST API. The underpinning of S3 interactions. While SDKs are the preferred method for most developers due to their convenience and built-in features, it's useful to know that S3 is fundamentally a REST-TFL web service. This means all interactions, whether initiated from the AWS Management Console, the AWS CLI, or any Oz SDK, ultimately translate into standard HTTP requests: GET, PUT, POST, DELETE, sent to S3 endpoints. These requests include specific headers, query parameters, and a cryptographic signature for authentication. When you might interact directly with the REST API, if you're using a programming language or platform without an officially supported AWS SDK. For very specific, low-level integration or performance tuning, requirements where the SDK's abstraction layers might introduce overhead you want to bypass. For learning and understanding how S3 works at its most fundamental level, which can aid in debugging or designing highly optimized custom integrations. 5.5 Handling errors and retries. Building robust applications means anticipating and handling errors gracefully. S3 operations can fail for various reasons. Client-side errors. These typically stem from issues with your request, such as incorrect permissions, access denied, a non-existent bucket, no such bucket, or a requested object not being found, no such key. For these, a direct error response is usually returned. Server-side errors. These are often transient issues, like temporary service unavailability, service unavailable, exceeding a rate limit, slowdown, or internal S3 errors. Oz SDKs typically include automatic retry mechanisms with exponential backoff for transient errors. This means they will automatically reattempt a failed request after increasing delays, up to a certain limit. However, for non-transient errors, like access denied, your application logic must explicitly catch these exceptions and respond appropriately, e.g., log the error, notify the user, provide specific feedback, or halt the process if it's a critical failure. Implementing custom retry logic can sometimes be necessary for very specific edge cases or complex workflows. 5.6 Security considerations for programmatic access. Using SDKs for programmatic access empowers your applications, but it also introduces critical security considerations that developers must adhere to. Never hardcode credentials. This is the most critical rule. Never embed your Oz access keys and secret keys directly into your application code, configuration files that are checked into source control, or directly onto servers. Use IAM roles for compute services. For applications running on Oz services like EC2 instances, AWS Lambda functions, Amazon ECS containers, or Amazon EKS pods, always use IAM roles. Attach an IAM role to the compute resource. Oz automatically and securely provides temporary, rotating credentials to your application through the instance metadata service or environment variables, allowing it to authenticate to S3 without your code ever having to manage long-lived keys. This is the most secure and recommended approach. Environment variables shared config files. For local development or applications running outside Oz where IAM roles are not applicable, e.g., a local script on your laptop, use environment variables AWS ACCSSKYID, AWS SECRETCCSSKY, or the Oz shared credentials file ~/ Oz/credentials. Tools like Oz Configure can help set this up. Least privilege. As discussed in Chapter 3, ensure that the IAM role or user your application assumes has only the minimal necessary S3 permissions, e.g., only S3 getObject if it only needs to read files, not S3, putObject or S3, deleteObject. Regularly review and audit these permissions to minimize the attack surface. Protect in-transit data, HTTPS. Always ensure your SDKs and direct API calls use HTTPS, when communicating with S3 endpoints. All modern SDKs default to this, but it's important to verify and enforce if custom setups are used. Conclusion of Chapter 5. Programming with S3 using AWS SDKs is fundamental to building dynamic, scalable cloud applications. By understanding how to initiate clients, perform basic CRUD, create, read, update, delete operations, leverage powerful features like multi-part uploads and presigned URLs, and implement robust error handling, developers can confidently integrate S3 into any modern application. Always prioritize security by adhering to best practices for credential management and least privilege. With the ability to manage data programmatically, we are now ready to explore one of S3's most popular developer use cases: hosting static websites. Chapter 6: Hosting static websites and single-page applications on S3. For many developers, the journey into cloud-native applications begins with deploying a website. While historically this involved configuring web servers, managing virtual machines, and patching operating systems, Amazon S3 fundamentally changes this landscape for static content. S3 is not just a storage solution. It's a powerful, cost-effective, and highly scalable platform for hosting static websites and single-page applications, SPAs. This chapter will guide you through the process, from basic bucket configuration to advanced setups with custom domains and HTTPS. 6.1. The power of static website hosting on S3. Static websites are those composed primarily of fixed HTML files, CSS stylesheets, JavaScript files, images, and other client-side assets. There are no server-side scripts, like PHP or Node.js, running on a server, dynamically generating pages. Modern web frameworks like React, Angular, and Vue.js often build into static bundles that fit this description, making S3 an ideal host. Why choose S3 for this purpose? Serverless simplicity. There are no servers to provision, patch, or manage. Oz handles all the underlying infrastructure, allowing you to focus purely on your website's content and functionality. Cost-effectiveness. You only pay for the storage you use, the data transferred, and the requests made. For many static sites, this translates to incredibly low operational costs, often just a few dollars a month. High availability and reliability. Leveraging S3's inherent 11.9s, durability, and distributed architecture, your website benefits from extreme resilience. If one server goes down, another seamlessly takes its place. Scalability. S3 scales automatically to handle any amount of traffic, from a handful of visitors to millions. There's no need to worry about your website going down during traffic spikes, as S3 is designed to handle internet-scale workloads. Global reach with CDN. When combined with services like CloudFront, which we'll discuss shortly, your website content can be cached at edge locations worldwide, making it load faster for users across the globe. 6.2. Configuring an S3 bucket for static website hosting. Enabling static website hosting on an S3 bucket is a straightforward process. Create an S3 bucket. First, you need an S3 bucket in your chosen AWS region. Remember the bucket naming rules from Chapter 2. If you want to use a custom domain later, the bucket name must exactly match your domain name, e.g., if your domain is www.example.com, your bucket must be named www.example.com. Enable static website hosting. Access the bucket's properties in the AWS Management Console. Here, you'll find an option to enable static website hosting. Index document. You'll specify an index document, e.g., index.html. This is the default page that S3 will serve when a user visits the root of your website, e.g., http your bucket name .s3 website oz region.amazonos.com / error document. You can optionally specify an error document, e.g., error HTML. S3 will serve this page when a user requests a non-existent path, e.g., a 404 not found error. This is particularly useful for single-page applications, as we'll discuss. Redirection rules optional. S3 allows you to define advanced redirection rules, for instance, to redirect requests for old URLs to new ones, or to redirect based on specific conditions. This can be handy for managing content changes. Upload your website files. Once hosting is enabled, upload all your website static files, HTML, CSS, JavaScript, images, fonts, directly into the root of this S3 bucket. You can do this using the AWS Management Console, the AWS CLI, Oz S3 Sync. S3 / your bucket name delete, or via an AWS SDK. Set a bucket policy for public access. By default, S3 buckets are private. For a website to be accessible over the internet, you must grant public read access. This is done with a bucket policy. Refer back to Chapter 3 on S3 security. Your policy will typically allow the S3 getObject action for the principal. Everyone, on all objects within your website bucket, ARN Oz S3, your bucket name /. Important security note. When making a bucket public, always review your Oz account's S3 public access block settings. If these are active, as recommended in Chapter 3, you may need to explicitly allow public access for this specific website bucket while maintaining blocking for all other buckets in your account. You should only grant public read access to the specific content that is intended to be public. Once these steps are complete, S3 will provide you with a unique website endpoint URL, e.g., http your bucket name .s3 website us east 1.amazonos.com. You can use this URL to access your website. 6.3 Integrating with custom domains and HTTPS. While S3's provided website endpoint works, it's generally not production ready. It uses S3's default unbranded domain and, critically, does not support HTTPS out of the box. For a professional, secure website, you need a custom domain, like www.example.com, and secure communication via HTTPS. This is where AWS CloudFront and AWS Route 53 come into the picture. 6.3.1 Securing with HTTPS and enhancing performance with CloudFront. AWS CloudFront is a content delivery network, CDN, service that works seamlessly with S3. It serves multiple crucial roles for static website hosting. HTTPS support. CloudFront integrates with AWS Certificate Manager, ACM, to provide free SSL TLS certificates for your custom domains. Your website visitors connect to CloudFront via HTTPS, and CloudFront then securely fetches content from your S3 bucket, often over HTTPS too. Global content delivery. CloudFront caches your website's content at edge locations, data centers around the world. When a user requests your content, it's served from the nearest edge location, dramatically reducing latency and improving loading speeds for global audiences. Security. CloudFront provides additional security layers, including protection against DDoS attacks and the ability to restrict direct access to your S3 bucket. How CloudFront and S3 work together. CloudFront distribution. You create a CloudFront distribution and configure its origin to be your S3 static website hosting endpoint. HTTPS configuration. You request or import an SSL TLS certificate for your custom domain through AWS Certificate Manager, ACM, in the US East 1, N Virginia. Region, a requirement for CloudFront certificates. You then associate this certificate with your CloudFront distribution. Origin Access Control, OAC, this is a critical security feature. Instead of making your entire S3 bucket publicly readable, you can configure your CloudFront distribution with an Origin Access Control, OAC. The OAC generates a special identity that you then add to your S3 bucket policy, granting permissions only to that CloudFront distribution. This ensures that users can only access your content through the secure CloudFront endpoint and cannot bypass the CDN to directly access your S3 bucket via its public URL. This is a significant security improvement over older methods. 6.3.2 Pointing your custom domain with Route 53. AWS Route 53 is a highly available and scalable cloud domain name system, DNS, web service. Once your CloudFront distribution is set up for your custom domain and HTTPS, you need to tell the internet how to reach it. Update DNS records. If your domain is managed by Route 53, AWS DNS service, you'll create an alias record that points your custom domain, e.g., www.example.com, to your CloudFront distribution's domain name. Alias records in Route 53 offer an advantage over traditional CNAMEs for root domains, like example.com without www. External DNS provider. If your domain is managed by another DNS provider, like GoDaddy or Namecheap, you'll update your CNAME record to point your custom domain to your CloudFront distribution's domain name. Once DNS propagation occurs, which can take minutes to hours, users visiting your custom domain name, e.g., https www.example.com, will be directed through CloudFront to your S3 hosted website, delivered securely over HTTPS. 6.4 Deployment workflows. For static websites, deployment is typically a process of copying your built website files to the S3 bucket. Manual uploads. For small, infrequent updates, directly using the AWS Management Console's Upload feature, or AWS S3CP, or AWS S3 Sync commands via the CLI is sufficient. Automated deployments with CI/CD. For professional projects, automated continuous integration, continuous deployment, CI/CD, pipelines are recommended. Workflow. When developers push code changes to a version control system, like GitHub, GitLab, or AWS Code Commit, a CI/CD service, like AWS Code Pipeline, GitHub Actions, Travis CI, or Jenkins, can be triggered. Build and test. The pipeline will build your static site, e.g., running npm run build for a React app, run tests, and if successful, proceed to deployment. Sync to S3. The build artifacts, your compiled HTML, CSS, JS files, are then automatically synced AWS S3 Sync to your S3 website bucket. CloudFront cache invalidation. Crucially, after new files are deployed to S3, the CloudFront cache needs to be invalidated. This tells CloudFront to pick up the new content from S3 rather than serving stale, cached versions. This is typically done with another CLI command or SDK call within the CI/CD pipeline after the S3 sync is complete. This automated approach ensures consistent, rapid, and error-free deployments, saving developer time and improving release velocity. 6.5 Single-page applications, SPAs considerations. Single-page applications, SPAs, present a unique challenge for static website hosting related to client-side routing. Traditional static sites use server-side routing, where example.com/about requests about HTML from the server. SPAs, however, use JavaScript to dynamically load content and change the URL path, e.g., from example.com to example.com/about without a full page reload. If a user tries to directly access example.com/about or refreshes the page, the browser sends that full path to S3. S3, not having a file named about, because it's part of the SPA's internal routing, returns a 404 error. To handle this, S3 and CloudFront can be configured. S3 error document for SPAs. The key to SPA routing on S3 is to configure the S3 buckets, error document, to be your index.html, or whatever your SPA's main entry point file is called. How it works. If S3 receives a request for a path that doesn't correspond to a physical file, e.g., example.com/settings, it sees it as a 404 error. Instead of returning a standard error HTML page, it will now return index.html. Your SPA's JavaScript takes over, reads the URL, and correctly renders the settings view client-side. CloudFront error pages. For robustness, you should configure CloudFront's custom error pages as well. You can tell CloudFront that when it receives a 403, forbidden, or 404, not found response from the S3 origin. It should instead return a 200 OK status code and serve your index.html as the response body. This ensures CloudFront doesn't cache the 404, and the SPA can load even if the initial S3 lookup fails for a non-existent route. This helps ensure consistent behavior. For more complex SPA routing or URL rewriting needs, CloudFront offers advanced features like Lambda at edge functions, which allow you to run serverless code at CloudFront's edge locations to intercept and modify requests and responses. While beyond the scope of a foundational chapter, these capabilities provide ultimate flexibility for advanced web applications. Conclusion of Chapter 6. Amazon S3, especially when combined with CloudFront and Route 53, provides a powerful, scalable, and genuinely serverless solution for hosting static websites and single-page applications. It eliminates the operational overhead of traditional web servers, allowing developers to focus on building compelling user experiences. Understanding its configurations for index error documents, public access, custom domains, and HTTPS is crucial for deploying modern web applications efficiently and securely. With your web content effectively served, we will now turn our attention to S3's role as a robust solution for data storage, ranging from backups to large-scale data lakes. Chapter 7. S3 for data storage. Backups, archives, and data lakes. While Amazon S3's role in delivering static websites is widely recognized, its most profound impact for developers often lies in its capabilities as a foundational data store. S3 isn't merely a place to put web assets. It's a versatile, highly durable, and cost-effective solution for everything from critical backups and long-term data archival to building massive, scalable data lakes. This chapter will explore how S3 underpins various data storage strategies, saving costs, enhancing resilience, and enabling advanced analytics. 7.1 S3 as a backup and recovery solution. Disaster can strike at any time. Hardware failure, accidental deletion, cybersecurity attacks, or natural calamities. Reliable backups are your last line of defense, and S3 is an ideal destination for them. Why S3 excels for backups? Extreme durability. With its 11 nines of durability, S3 offers a level of data protection far beyond what most organizations can achieve with on-premises storage. Your backup data is redundantly stored across multiple data centers, virtually eliminating the risk of data loss due to hardware failures. Scalability. S3's limitless capacity means you never have to worry about running out of space for your backups, no matter how much data you accumulate. Cost-effectiveness. Its pay-as-you-go model and diverse storage classes, as discussed in Chapter 2, allow you to store massive amounts of backup data at very low costs, especially as older backups can be tiered to colder storage. Accessibility. Backup data in S3 is instantly accessible via API, making recovery quick and efficient, whether through automated scripts or manual retrieval. Off-site storage. Backing up to S3 automatically provides off-site storage, protecting against localized disasters affecting your primary data center. Types of data to back up to S3, database dumps, regular snapshots or logical exports of your databases, e.g., MySQL, PostgreSQL, MongoDB. Application configurations, critical application settings, environment variables, and deployment artifacts. File system backups, archives of file servers, user home directories, or shared network drives. Virtual machine server snapshots, images of entire compute instances. How it works: conceptual, scheduled jobs. Developers often implement scripts or use third-party backup tools that run on a schedule, e.g., nightly, to export data from their primary systems. Stream to S3. This exported data is then securely streamed or uploaded directly to a designated S3 bucket. Versioning for point-in-time recovery. Enabling versioning on the backup bucket, Chapter 4, is highly recommended. If a backup file is accidentally overwritten or corrupted, older valid versions are retained, allowing for point-in-time recovery. Lifecycle for cost optimization. As backups age, they are typically accessed less frequently, but still needed for long-term retention policies. Lifecycle rules automate the transition of these older backups from S3 standard to S3 standard IA, and eventually to S3 Glacier or Glacier Deep Archive, significantly reducing storage costs. Anecdote: a small e-commerce startup, initially relying on a NAS device for its daily database backups, learned a harsh lesson when their office suffered a power surge, frying the NAS. Their recovery was only possible because, a month prior, a developer had implemented a simple script to also push compressed database dumps nightly to S3. They were back online within hours using the S3 data, rather than facing weeks of data reconstruction or irreparable loss. 7.2 Archiving with S3 Glacier and S3 Glacier Deep Archive. Beyond active backups that might need frequent retrieval, many organizations have data that must be retained for years, for regulatory compliance, legal discovery, or historical purposes, but is rarely, if ever, accessed. For this, S3 Glacier and S3 Glacier Deep Archive are purpose-built. The archival advantage: lowest storage costs. These storage classes offer the absolute lowest costs per gigabyte of storage in the cloud, making multi-year or multi-decade retention economically viable for vast datasets. Deep immutability. When combined with S3 Object Lock Chapter 4, these archives provide immutable storage, essential for compliance mandates. Write once, read many worm. Glacier versus Deep Archive, the retrieval trade-off. S3 Glacier, designed for data accessed occasionally, e.g. once or twice a year. While storage is cheap, retrieval incurs costs and takes time. You have 3 retrieval options. Expedited, typically completes within 1 to 5 minutes. Best for urgent, small retrievals. Standard, typically completes within 3 to 5 hours, suitable for most planned retrievals. Bulk, typically completes within 5 to 12 hours. Designed for large datasets where time is less critical. S3 Glacier Deep Archive, optimal for data accessed very rarely, perhaps once a year or less. Its storage costs are even lower than standard Glacier, but retrieval times are longer and costs are carefully structured. Standard typically completes within 12 hours. Bulk typically completes within 48 hours. Developer perspective: initiating retrieval conceptual. When an object is in Glacier or Deep Archive, it's not immediately downloadable. To access it, your application must first initiate a restore request via the SDK or CLI. You specify the object key, the desired retrieval tier, expedited, standard, bulk, and a duration for which the restored copy will be available, e.g., 24 hours to 30 days. Once the restoration is complete, after the specified retrieval time, a temporary copy of the object becomes available in S3 standard storage. Your application can then get object as normal. After the specified duration, the temporary copy is removed, but the original object remains safely in cold storage. Case example: a media production company archives all raw footage from every film and documentary. This data is rarely touched, but must be preserved for decades for potential re-edits or legal inquiries. Storing petabytes of this data in S3 Glacier Deep Archive ensures extreme longevity at minimal cost, knowing they can retrieve it within a day if needed. 7.3 Building a data lake with S3. In today's data-driven world, organizations collect vast amounts of information: application logs, clickstream data, IoT sensor data, social media feeds, and more. A data lake on S3 provides a centralized, scalable, and highly flexible repository for all this data, regardless of its original format. What is a data lake? Unlike a traditional data warehouse, which stores highly structured, processed data for specific analytical queries, a data lake is designed to store raw data in its native format. It's a scheme-on-read approach, meaning you don't need to define the data's structure, schema, until you're ready to analyze it. This flexibility supports exploratory analytics and machine learning. Why S3 is the cornerstone of data lakes. Unmatched scalability and cost. S3's virtually unlimited capacity and low storage costs make it the ideal foundation for data lakes that can grow to exabytes. Format agnostic. S3 can store any data format: structured data, CSV, JSON, semi-structured data, XML, Avro, or unstructured data, images, video, text documents. deep integration with AWS analytics tools. S3 seamlessly integrates with a broad ecosystem of Oz services designed for data processing and analytics, including Amazon Athena, serverless query service that allows you to query data directly on S3 using standard SQL. AWS Glue, a fully managed extract, transform, and load ETL service that helps you prepare and load your data for analytics. Its Glue data catalog acts as a metadata repository for your data lake. Amazon EMR, a managed cluster platform for running big data frameworks like Apache Spark, Hadoop, Presto, and Hive on data in S3. Amazon Redshift Spectrum allows Redshift data warehouse users to query data directly on S3. Amazon SageMaker, for machine learning model training on data stored in S3. Principles of an S3 data lake. Raw zone, data is ingested directly into a raw zone, an S3 prefix or bucket, in its original unprocessed format. This ensures data fidelity for future analysis. Processing zone. The data is then incrementally processed and transformed in a processing zone. This might involve cleaning, enriching, or transforming data into more optimized formats for analytics, e.g., Parquet or Orc. Curated zone. Finally, data moves to a curated zone, where it's highly optimized for consumption by business intelligence tools and machine learning models. This involves denormalization, aggregation, and specific partitioning. Data organization and partitioning. For performance with analytics tools, data in S3 data lakes is often organized and partitioned logically. A common practice is time-based partitioning, such as S3 // my data lake /logs /year equals 2023 /month equals 01 /day equals 15 /hour equals 10 /. This allows query engines to scan only the relevant subsets of data, dramatically speeding up query execution and reducing costs. Ingestion, conceptual. Data can be streamed to S3 using services like AWS Kinesis Firehose for real-time ingestion, or transferred in batches using AWS DataSync, direct uploads via CLI SDK, or AWS Snowball for very large offline transfers. Case study: a global ride-sharing company collects massive amounts of operational data, ride start-end locations, driver patterns, surge pricing events. They store all this raw data in an S3 data lake. Data scientists then use Athena to run ad hoc queries, and Spark on EMR to build machine learning models on this raw data, predicting demand, optimizing routes, and personalizing user experiences. 7.4 S3 Select and Glacier Select, querying data directly in S3. Traditionally, to query data stored in S3, you had to retrieve the entire object, then process it on a compute instance, like an EC2 server or Lambda function, to extract the relevant information. This could be slow and costly for large files. S3 Select and Glacier Select revolutionized this by enabling you to query directly on the S3 object itself. How they work. These services allow you to use simple SQL queries to filter the contents of an S3 object and retrieve only the subset of data you need. The query execution happens seamlessly within S3, avoiding the need to download the entire object to your application first. Key benefits: performance, significantly faster data retrieval, especially for large objects, as only the queried data is transferred. Cost savings, you only pay for the data scanned and the data returned, not the entire object. This dramatically reduces data transfer costs. Simplified architecture, no need to provision and manage servers just for data filtering tasks. Supported formats, S3 Select and Glacier Select support data stored in CSV, comma-separated values, JSON, JavaScript object notation, both records and arrays, Apache Parquet, a columnar storage format. Conceptual use cases for developers, log analysis. Extract specific log entries, e.g., all errors from a specific service within a large log file without downloading megabytes or gigabytes of non-error messages. Filtering customer data. From a large CSV file of customer records, extract only the records for customers in a specific city or those who made a purchase over a certain amount. IoT data querying. filter specific sensor readings from large IoT data dumps stored as JSON lines. Glacier Select Specific. You can run S3 Select queries directly on data that is still in S3 Glacier or S3 Glacier Deep Archive, but you must specify a retrieval option, expedited, standard, or bulk, similar to a full object retrieval. This means you still wait for the data to become available, but you only retrieve the portion of the data you need for the query result. Example scenario: a developer has log files that grow to several gigabytes each day in S3. They need to analyze a transient issue that happened yesterday at a specific time. Instead of downloading the 5 GB log file to their laptop and using grep, they use S3 Select, conceptually running a query like select from mylogfile CSV where timestamp between and level equals error. S3 Select returns only the small filtered result set, saving time and bandwidth. Conclusion of Chapter 7. Amazon S3 stands as a robust, versatile, and hyperscalable solution for a wide range of data storage needs for developers. From providing resilient backup and recovery targets that safeguard against unforeseen events, to offering incredibly cost-effective long-term archival for regulatory compliance, and serving as the flexible, expansive foundation for modern data lakes, S3 is central to data management in the cloud. Furthermore, tools like S3 Select empower developers to interact with this vast data directly and efficiently. Understanding and leveraging S3's capabilities in these areas is crucial for building data-driven applications that are reliable, cost-optimized, and ready for future analytics challenges. Next, we will delve deeper into strategies for enhancing performance and, critically, reducing costs when working with S3. Chapter 8. Enhancing performance and reducing costs with S3 strategies. Building effective cloud applications isn't just about functionality. It's equally about performance and cost efficiency. A fast application that drains your budget isn't sustainable, and a cheap application that's too slow to be useful defeats its purpose. Amazon S3, while offering immense power, requires a proactive approach from developers to optimize both its speed and its expenses. This chapter delves into practical strategies for maximizing S3 performance for your applications and, crucially, for minimizing your S3 bill. 8.1 The Dual Imperative: Performance and Cost. In the cloud, these two factors are inextricably linked. Often, strategies designed to improve performance, like caching data closer to users, also lead to cost savings by reducing direct accesses to the primary storage. Conversely, poor performance can sometimes be attributed to inefficient cost-saving measures or simply neglecting to plan for either. As a developer, equipping yourself with the knowledge to balance these priorities is key to building truly successful and scalable cloud solutions. 8.2 S3 Performance Optimization. While S3 is renowned for its scalability and high throughput, certain strategies ensure your applications get the most out of it. Achieving high request rates. S3's automatic scaling. S3 is designed to automatically scale to handle very high request rates. It partitions data based on object prefixes, the start of the object's key, while older advice emphasized randomizing prefixes to distribute load. Modern S3 has evolved significantly and handles high request rates for any prefix without requiring random characters. However, maintaining good key naming conventions, as discussed in Chapter 2, for logical grouping and readability remains important. Error handling and retries. As covered in Chapter 5, SDKs include automatic retries with exponential backoff for transient errors. Ensuring your application properly utilizes these or implements its own robust retry logic for extreme workloads is crucial to maintain high throughput even during temporary service fluctuations. Accelerating data transfers. S3 Transfer Acceleration. This feature enables fast, easy, and secure transfers of files over long distances between your client and an S3 bucket. When you enable transfer acceleration on a bucket, data travels over AWS-optimized network path, routing uploads and downloads through CloudFront's globally distributed edge locations. This is particularly beneficial if clients are geographically distant from your S3 bucket's AWS region or if you're dealing with very large files. You simply point your S3 client to the transfer acceleration endpoint for your bucket, and S3 handles the rest. Multi-part uploads. Recap from Chapter 5. For large files, typically 100 MB, always leverage multi-part uploads. This technique breaks the file into smaller parts that can be uploaded concurrently, significantly reducing the total upload time. SDKs often manage this automatically, but understanding its mechanism is powerful for troubleshooting and custom implementations. Leveraging Content Delivery Networks, CDNs, with Amazon CloudFront. As detailed in Chapter 6, CloudFront is a crucial component for performance. For content that needs to be delivered to end users, like images, videos, static website assets, and downloadable files, placing CloudFront in front of your S3 bucket dramatically improves performance by caching. Content is cached at CloudFront's global edge locations, closer to your users. Subsequent requests for the same content are served directly from the cache, reducing latency and avoiding round trips to S3. Optimized routing. CloudFront's network intelligently routes user requests to the closest, fastest edge location. Offloading S3. By serving cached content, CloudFront reduces the number of direct requests to your S3 bucket, further improving S3's responsiveness for other, non-cacheable data. Parallelism in data processing. Whether reading or writing, performing operations on multiple objects concurrently can saturate network bandwidth and maximize S3 throughput. Instead of processing files one by one, design your applications to download or upload batches of files in parallel, perhaps using multiple threads or asynchronous programming models. 8.3. Understanding S3 costs. The bill breakdown. To effectively reduce costs, you must first understand how S3 bills you. S3 pricing is complex because it's highly granular and varies by region and storage class. The core components are storage per GB per month. This is the most obvious cost. It's calculated based on the total average gigabytes stored per month, and this rate varies significantly by storage class. S3 Standard is the most expensive per GB, while Glacier Deep Archive is the least. Requests per 1,000 requests. Every interaction with S3 counts as a request. This includes PUT uploads, GET downloads, listing objects, copy, and delete. The cost per 1,000 requests varies by request type and storage class, e.g., retrieving an object from Glacier is more expensive per request than from Standard. Data transfer out per GB. This is often a surprisingly significant cost. You are charged for data transferred out of S3 to the public internet or across AWS regions. Data transfer into S3 is always free. Data transfer within the same AWS region and availability zone, e.g., S3 to an EC2 instance in the same AZ, is usually free. Data transfer to a CloudFront distribution is free. Data transfer between AWS regions, e.g., for cross-region replication, or if a resource in one region accesses a bucket in another, has a cost. Retrieval. For infrequent access, IA and archive Glacier, storage classes, you incur a per gigabyte retrieval charge in addition to the request cost. This cost varies based on the amount of data retrieved and the retrieval speed tier for Glacier. Other costs, lifecycle transition requests. Each time an object is transitioned to a different storage class due to a lifecycle rule, a small request charge applies. S3 Intelligent Tiering Monitoring and Automation. This storage class, Chapter 2, has a small per-object monthly charge for its automatic tiering capabilities. S3 Select Glacier Select Scanning. You're charged for the amount of data scanned and data returned while querying data directly. Replication costs. For cross-region or same-region replication, Chapter 4, you pay for the storage in the destination bucket, the PUT requests to write the objects, and the data transfer if it's cross-region. 8.4 S3 Cost Reduction Strategies. Now that you understand the billing components, here are actionable strategies to reduce your S3 costs. 1. Storage class optimization, the biggest lever. This is the most impactful strategy. Meticulously match your data's access patterns to the correct storage class as detailed in Chapter 2. S3 Standard, for frequently accessed data. S3 Intelligent Tiering. for data with unknown or dynamically changing access patterns. This class pays for itself if access patterns are truly unpredictable, automatically moving data between frequent and infrequent access tiers. S3 Standard IA/One Zone IA for long-lived, infrequently accessed data. Use One Zone IA if the data is easily reconstructible and you can tolerate its lower resilience, as it's stored in a single AZ. S3 Glacier/Glacier Deep Archive for long-term archives. Understand the retrieval costs and times. Don't use Glacier if you need instant access. 2. Implement S3 Lifecycle Rules, automate optimization. As explored in Chapter 4, lifecycle rules are your automation engine for cost savings. Automated transitions. Set rules to automatically transition objects to cheaper storage classes as they age and become less frequently accessed. For example, logs that are hot for 7 days might transition to Standard IA. After 30 days, possibly to Glacier. Automated expiration deletion. Set rules to automatically delete objects or specific versions of objects after their retention period expires. Don't pay for data you no longer need. Manage non-current versions. If versioning is enabled, non-current older object versions still incur storage costs. Set lifecycle rules to expire these non-current versions after a defined period or after a certain number of older versions have accumulated. 3. Ruthlessly delete unnecessary data. Beyond lifecycle rules, actively clean up redundant or temporary files. Incomplete multi-part uploads. Large multi-part uploads that never completed can leave behind orphaned parts, incurring storage costs. Regularly examine and clean up these lingering incomplete uploads. Redundant backups. If your backup strategy involves creating many versions, ensure older, irrelevant backups are eventually discarded or properly archived. 4. Optimize data transfer out. Data transfer out to the internet is a significant cost. Use CloudFront for public content. As mentioned, data transfer out from S3 to CloudFront is free. CloudFront then serves the content to users from its edge locations, and CloudFront's egress costs are typically lower than S3's direct egress to the internet, particularly at scale and with the added benefit of performance. Keep data within AWS network. Whenever possible, ensure your compute resources, EC2, Lambda, accessing S3 data are in the same AWS region to leverage free data transfer within the region. Even better, keep them in the same availability zone for maximal cost savings and minimal latency. VPC endpoints for S3. For resources within your virtual private cloud, VPC, access S3 via a VPC endpoint for S3. This routes traffic directly between your VPC and S3 using AWS private network instead of traversing the internet, enhancing security and reducing data transfer costs. 5. Compress your data before upload. Compressing files, e.g., using gzip for text files or efficient image-video codecs, before uploading them to S3 directly reduces the amount of storage you consume. This also has the secondary benefit of reducing data transfer costs when the data is downloaded. 6. Right sizing and smart object design. Consider if your data needs to be stored at its highest possible quality or resolution, if not always necessary. For example, store multiple resolutions of images and serve the appropriate size. Avoid storing many tiny objects if they can be aggregated. Each object incurs a request cost, so consolidating very small, frequently accessed objects can sometimes reduce request charges. 7. Use S3 Storage Lens for deeper cost insights. S3 Storage Lens is a cloud storage analytics feature that provides organization-wide visibility into your S3 usage and activity. It can help you identify cost optimization opportunities by showing which buckets or prefixes are contributing the most to your storage bill. Objects that are being frequently accessed but are in more expensive storage classes. Infrequently accessed objects that could be transitioned to colder storage. Metrics on incomplete multi-part uploads. This global view allows you to make informed decisions about where to apply your optimization efforts. Case study: optimizing an archival system for a genomics startup. A small genomics startup initially dumped all their raw and process sequencing data into an S3 standard bucket. Within a year, their S3 bills skyrocketed to thousands of dollars per month, primarily due to petabytes of old data they rarely accessed. They urgently needed to control costs without compromising data integrity. The problem: all data, regardless of age or access frequency, was in the most expensive S3 standard storage class. The solution implemented by the developers: categorization. They identified three main data types: hot data, most recent sequencing runs, accessed frequently for immediate analysis; warm data, completed projects, rarely accessed, but might need quick retrieval; cold data, archived, finalized sequence data, needed for compliance, almost never accessed. Lifecycle rules. They set up lifecycle rules based on these categories. All new raw data went to S3 standard. After 60 days, data automatically transitioned to S3 standard IA. After 180 days, data automatically transitioned to S3 Glacier Flexible Retrieval. After 2 years, data transitioned to S3 Glacier Deep Archive. Cleanup. They used S3 Storage Lens to identify any incomplete multi-part uploads and deleted them. They also created a clear data retention policy and expired older, non-compliant data. Batch processing for existing data. For the petabytes of existing data already in S3 standard, they created an S3 inventory report and used S3 batch operations. Chapter 4. To initiate a one-time process to transition the older data to the appropriate IA and Glacier storage classes. The outcome? Their S3 bill dropped by over 80% within a few months, demonstrating the immense power of intelligent storage class management and automated lifecycle policies. Performance for fresh data remained high, while retrieval costs for archived data were acceptable for their infrequent access patterns. Conclusion of Chapter 8. Mastering Amazon S3 goes beyond merely storing data. It involves a continuous effort to balance performance, cost, and functionality. By judiciously selecting storage classes, automating data lifecycle management, leveraging powerful tools like CloudFront and transfer acceleration, and diligently monitoring your usage, developers can build highly efficient, high-performing, and financially sustainable cloud applications. The power to control your S3, spend, and enhance its speed lies directly in understanding and applying these strategies. Next, we will explore how S3 can become a central component in event-driven architectures, triggering serverless functions to process your data automatically. Chapter 9. Event-driven architectures with S3 event notifications and Oz Lambda. In the traditional request-response model of application development, systems often ask for data or poll for changes. In contrast, an event-driven architecture, EDA, allows systems to react to events as they occur. This paradigm shift can lead to more scalable, resilient, and loosely coupled applications. Amazon S3, being a core data store, is a natural fit for an event source. By leveraging S3 event notifications, developers can build powerful, serverless, and highly responsive applications that automatically react to changes in their data. 9.1 Event-Driven Fundamentals. How S3 triggers action. At its heart, an event-driven architecture means your application's components communicate by emitting and reacting to events. An event is simply a change in state or an update, such as an object was created or a customer placed an order. Instead of constantly checking S3 for new files, S3 can proactively tell other services when something changes. This fundamental shift from polling to event-driven communication offers several advantages. Decoupling. Your data storage, S3, is separate from your data processing logic, e.g., a Lambda function. They don't need to know much about each other beyond the event contract. Scalability. Each component can scale independently. S3 handles object storage, while your processing logic scales on demand when events occur. Resilience. If a processing component temporarily fails, S3 still stores the data, and the event can often be retried or routed to a dead letter queue, ensuring no data is lost. Real-time processing enables near real-time reactions to data changes, crucial for many modern applications. 9.2 Fundamentals of S3 Event Notifications. S3 event notifications are the mechanism by which S3 informs other AWS services or external endpoints about specific activities happening within your buckets. When you configure an S3 event notification, you specify the bucket, the S3 bucket you want to monitor for events, event types, which specific S3 actions should trigger a notification. Common event types include S3 object created. Any new object creation includes initial uploads, copies, multi-part uploads. S3 object created put, specifically for objects uploaded via PUT. S3 object removed. Any object deletion includes delete markers. S3 object restore, when objects are restored from Glacier storage. S3 reduced redundancy lost object, when S3 detects a loss of an object stored in the now deprecated reduced redundancy storage class, though this is less relevant for new systems. Prefix and suffix filters, optional. You can narrow down the scope of events. For instance, you could configure a notification to trigger only when an object is created with a key starting with images and ending with JPG. This allows fine-grained control and prevents unnecessary processing. Destination, where S3 should send the notification. S3 supports 3 direct AWS service destinations: Amazon SNS, Simple Notification Service, a messaging service for fan-out messaging. S3 sends a notification to an SNS topic, and that topic can then deliver the message to multiple subscribers, e.g., multiple Lambda functions, SQS queues, email, HTTP endpoints. Amazon SQS, Simple Queue Service, a message queuing service. S3 sends notifications to an SQS queue. This is ideal when you need a reliable, decoupled buffer and one or more worker applications, consumers, will pull messages from the queue for processing. It's excellent for handling processing spikes or ensuring orderly processing. Oz Lambda, a serverless compute service. S3 directly invokes a specified Lambda function when an event occurs. This is widely used for immediate, real-time processing of S3 data. When an event occurs, S3 sends a JSON message to your configured destination. This message contains critical information about the event, such as the bucket name, the object key, the event time, and details about the object, e.g., size, ETag, version ID if versioning is on. Your downstream application consumes this JSON payload to understand what happened and how to react. 9.3 S3 and AWS Lambda, the serverless synergy. The combination of S3 event notifications and Oz Lambda is one of the most powerful and popular patterns in serverless application development. They are a perfect match because Lambda is serverless, no servers to provision, manage, or scale. Oz entirely handles the underlying infrastructure. Lambda is event-driven. It's designed to be invoked by events, fitting seamlessly into S3's notification system. Lambda scales automatically. As S3 receives a burst of new objects, Lambda automatically scales out its compute capacity to process all incoming events concurrently, without you needing to manually adjust resources. Lambda is cost-effective. You only pay for the compute time consumed when your Lambda function is actively running, often down to the millisecond. Conceptual flow, from object upload to Lambda processing. A user or application uploads an object, e.g., an image file, to a specific S3 bucket or a particular folder prefix within that bucket. S3 detects the object-created event based on your notification configuration. S3 generates a JSON event message containing details about the newly created object. S3 sends this event message directly to your configured Oz Lambda function. AWS Lambda receives the event, unpacks the JSON message, and invokes your predefined function. Your Lambda function's code executes, typically downloading the object, or a portion of it, from S3, performing some processing, and then perhaps uploading a new object to a different S3 location, updating a database, or sending a notification. Permissions, reminder, security. For this flow to work, 2 sets of permissions are crucial. Your Lambda function's execution role must have the necessary IAM permissions to read from the S3 bucket that triggered it, e.g. S3, getObject, and any other services it interacts with, e.g. S3, putObject for output, database write permissions. S3 must have permission to invoke your Lambda function. When you create the S3 event notification rule, AWS typically sets this up automatically by adding a resource-based policy to your Lambda function that allows s3.amazonos.com to invoke it. 9.4 Common serverless patterns with S3 and Lambda. The S3 Lambda combination enables a wide array of powerful use cases: one, image processing and thumbnail generation. Scenario: an online photo gallery needs to generate multiple sizes of an image, e.g., full size, web-optimized, thumbnail, and perhaps add a watermark whenever a new photo is uploaded. Flow: user uploads a high-resolution image to an S3 bucket, e.g., My Raw Images. This triggers an S3 notification. A Lambda function is invoked, which downloads the raw image, uses an image processing library to create different versions, and then uploads these processed images to other appropriate S3 buckets, e.g., My Web Images, My Thumbnails. 2. Data transformation and ETL, extract, transform, load. Scenario: a company receives daily CSV files from partners containing customer data. Before this data can be used for analytics, it needs to be validated, cleaned, and converted to a more optimized format like Apache Parquet. Flow: the partner uploads a new CSV file to a raw data S3 bucket. An S3 event notification triggers a Lambda function. This function reads the CSV, applies validation and cleansing rules, transforms the data structure, and then writes the processed data as a Parquet file to a process data S3 bucket, perhaps partitioning it by date, e.g., process data /year equals 2023/month equals 01/day equals 15/datapark. 3. Video transcoding and media processing. Scenario: a video streaming service wants to automatically convert user-uploaded videos into various formats and resolutions suitable for different devices. Flow: a user uploads a video to a source video's S3 bucket. An S3 object-created event triggers a Lambda function. This Lambda function initiates a job with a dedicated media transcoding service, like AWS Elemental Media Convert or Oz Media Services, to process the video. Once transcoding is complete, the output video files are stored back into other S3 buckets, e.g., encoded videos mobile, encoded videos /HD. 4. Real-time analytics and indexing. Scenario: an application generates fine-grained usage logs periodically saved as small JSON files to S3. These logs need to be quickly indexed for searching and real-time dashboard updates. Flow: a new log file lands in an application logs S3 bucket. A Lambda function is triggered, which parses the log file, extracts key metrics and events, and then pushes this data to an analytics engine like Amazon Elasticsearch Service for search or Amazon Kinesis for further streaming to a data warehouse. 5. Document processing. Scenario: an accounting department regularly receives scanned PDF invoices that need data extracted and validated. Flow: scanned invoice PDFs are uploaded to an invoices S3 bucket. A Lambda function is triggered. This function uses a service like Amazon Textract for OCR and data extraction from documents to pull out details like invoice number, total amount, and vendor. This extracted data is then stored in a database or another S3 bucket in a structured format for further processing. 9.5 Security of event-driven flows. While powerful, these event-driven patterns require careful security consideration. Least privilege. As always, adhere strictly to the principle of least privilege. Your Lambda function's IAM execution role should have only the minimum S3 permissions required, e.g., S3, get object on the source bucket, S3, put object on the destination bucket, and permissions for any other services it interacts with. Avoid granting S3 unless absolutely necessary for administrative functions. Input validation. Your Lambda function should always validate the input it receives from the S3 event. Do not implicitly trust the event payload. For instance, confirm the bucket and object key exist and are of the expected format before attempting to download. This protects against malformed events or potential injection attacks. Protect sensitive data in S3. If your S3 bucket contains sensitive data, ensure it is encrypted at rest, Chapter 3, and that its public access block settings are appropriately configured to prevent accidental exposure. Logging and monitoring. Ensure your Lambda functions log their activity to AWS CloudWatch logs and review these logs regularly for unexpected behavior or errors. Error handling and dead letter queues, DLQS. For SQS or SNS destinations, define a dead letter queue, DLQ. If S3 fails to deliver an event repeatedly, or if your Lambda function processes an event but encounters an unrecoverable error, the event can be sent to a DLQ. This prevents data loss and allows you to inspect and manually retry failed events. 9.6 Considerations and Best Practices. Idempotency. S3 event notifications guarantee at least once delivery. This means it's possible, though rare, for your Lambda function to be invoked multiple times for the same event. Design your Lambda function to be idempotent. Processing the same event multiple times should produce the same result as processing it just once. For example, if generating a thumbnail, check if the thumbnail already exists before creating it again. Concurrency limits. Lambda functions have concurrency limits. If a massive burst of S3 events occurs, you might hit this limit. Consider if your Lambda function needs a higher dedicated concurrency. For extremely high volumes, especially of small objects, routing events through an SQS queue first might be beneficial, as SQS can buffer messages while your Lambda processes them in a more controlled, batch-like fashion. Error handling within Lambda. Implement robust error handling, e.g., try-catch blocks, within your Lambda code to gracefully manage unexpected data formats, external service failures, or other application-level issues. Return clear error responses. Object size and memory. Be mindful of the size of objects your Lambda function downloads. Lambda functions have memory limits. For extremely large S3 objects, consider using S3 Select, Chapter 7, to filter data on the object itself before downloading, or use other services like AWS Batch or Amazon EMR for heavy batch processing. Asynchronous nature. Remember that S3 event-driven processing is asynchronous. Your application might upload a file, and the processing of that file happens later. If your user interface needs synchronous feedback about the processing outcome, you'll need additional mechanisms, e.g., WebSockets, polling a status database, or a more involved step function. Anecdote: the photography studio's transformation. A mid-sized online photography studio specialized in event photos. Their traditional workflow involved photographers uploading thousands of high-resolution images to a private server weekly. A small team of retouchers then manually downloaded these images, resized them for web display, added watermarks, and uploaded them to a public gallery. This was a tedious, time-consuming process that bottlenecked their entire operation. By adopting an S3 event-driven architecture, they revolutionized their workflow. Photographers now upload images directly to a private S3 bucket. An S3 object-created event triggers a Lambda function that automatically downloads the high-resolution image, generates 3 different sizes, original, web-optimized, thumbnail, adds a small watermark to the web and thumbnail versions, uploads these processed images to different S3 buckets, public-facing for the gallery, private for archives, updates a database with image metadata. This serverless solution eliminated days of manual work, significantly reduced operational costs, and allowed the studio to deliver content to customers much faster, freeing their team to focus on more creative tasks. Conclusion of Chapter 9. S3 event notifications, particularly when coupled with AWS Lambda, unlock a vast array of possibilities for building responsive, scalable, and cost-effective event-driven architectures. By designing your applications around data changes in S3, you can automate critical workflows, from real-time media processing to complex data pipelines, with minimal operational overhead. Understanding how to configure these events, build resilient Lambda functions, and secure the entire flow is a vital skill for any cloud developer. In the next chapter, we'll continue exploring S3's ecosystem by examining its powerful integrations with other key AWS services. Chapter 10, Integrating S3 with other AWS services, CloudFront, Athena, and more. Amazon S3 isn't just a powerful standalone storage service. It's also a central hub that integrates seamlessly with a vast array of other AWS services. This interconnectedness allows developers to build sophisticated, highly scalable, and cost-effective solutions for content delivery, data analytics, machine learning, and more. Understanding these integrations is key to unlocking the full potential of S3 as a fundamental building block in your cloud architecture. 10.1 S3 and Amazon CloudFront. Global content delivery. We touched upon CloudFront in Chapter 6 for static website hosting, but its role extends far beyond that. Amazon CloudFront is a fast content delivery network, CDN service that securely delivers data, videos, applications, and APIs to customers globally with low latency and high transfer speeds. How they integrate, recap, and deep dive. Origin. S3 buckets are commonly configured as origins for CloudFront distributions. This means when a user requests content, CloudFront first looks for it in its cache. If not found, it fetches it from the designated S3 bucket. Edge locations. CloudFront caches content at its global network of edge locations, data centers. When a request comes in, it's routed to the nearest edge location. If the content is there, it's served immediately, dramatically reducing latency. HTTPS. CloudFront allows you to serve content over HTTPS using custom domains and provides free SSL TLS certificates through AWS Certificate Manager. This is crucial for web security and user trust. Origin Access Control, OAC. As discussed in Chapter 6, OAC is the recommended, secure way to restrict direct access to your S3 bucket. Instead of making the bucket publicly readable, you configure CloudFront's OAC to act as the sole gateway that can retrieve content from your S3 bucket, ensuring all traffic flows through the CDN. This enhances overall security and ensures your caching and other CloudFront rules are enforced. Benefits of this integration. Performance. Faster loading times for your users globally due to content caching at the edge. Cost reduction. Data transfer from S3 to CloudFront is free. CloudFront's egress costs to the internet can be more economical than S3's direct egress, especially at scale. Scalability. Effortlessly handles traffic spikes as CloudFront is designed for internet-scale delivery. Enhanced security. Protects your S3 origin from direct access and provides additional layers of defense against volumetric attacks like DDoS. Dynamic content acceleration. While optimal for static content, CloudFront can also accelerate dynamic content delivery by optimizing routes to origin servers. Use cases. Delivering static assets for web applications, streaming video and audio content, distributing software updates, or serving various types of downloadable files globally. 10.2 S3 and Amazon Athena. Serverless analytics on your data lake. Amazon Athena is an interactive query service that makes it easy to analyze data directly in Amazon S3 using standard SQL. It's truly serverless, meaning you don't provision, manage, or tune any servers or data warehouses. How they integrate. Schema on read. Athena integrates with AWS Glue Data Catalog. You define tables in the Glue Data Catalog that point to your data files stored in S3. These tables describe the schema of your data, but the data itself remains in S3. Standard SQL. Once your tables are defined, you can run standard SQL queries against them directly from the Athena console, JDBC ODBC drivers, or programmatic APIs. Data formats. Athena can query a wide range of data formats stored in S3, including CSV, JSON, ORC, Avro, and Parquet. For optimal performance and cost, columnar formats like Parquet are highly recommended as Athena only scans the columns it needs. Benefits of this integration. Cost-effective. You pay only for the amount of data scanned per query. No charges for idle compute. Scalable. Scales automatically to run complex queries on terabytes or petabytes of data. Flexible. Ideal for ad hoc queries, data exploration, and transforming raw data without needing to load it into a separate data warehouse. Simplified data lake architecture. Provides an easy-to-use SQL interface directly on your S3 data lake. Use cases. Analyzing application logs, querying clickstream data, performing exploratory data analysis on IoT sensor data, generating reports from raw business data, or building data pipelines that transform data from one S3 location to another. 10.3 S3 and AWS Glue, Data Cataloging and ETL. AWS Glue is a fully managed extract, transform, and load (ETL) service that makes it easy for customers to prepare and load their data for analytics. Glue is pivotal in managing an S3-based data lake. How they integrate: Glue Data Catalog. This acts as a centralized metadata repository for your S3 data lake. Glue crawlers can crawl your S3 buckets, infer the schema of your data, e.g., CSV, JSON, Parquet files, and populate the data catalog with table definitions. These definitions are then used by other services like Athena, Redshift Spectrum, and EMR. Glue ETL jobs. You can create Glue ETL jobs using Python with Apache Spark or AWS Glue Studio that read, process, and write data from and to S3. These jobs can perform data cleaning, transformation, aggregation, and format conversion. Benefits of this integration: automated schema discovery. Simplifies the process of understanding the structure of diverse datasets in S3. Managed ETL. No need to manage Spark clusters. Glue handles the scaling and execution of your ETL workflows. Centralized metadata. Provides a single source of truth for the schema of all data in your S3 data lake, facilitating data governance and discovery. Use cases: converting raw CSV logs to optimized Parquet files, joining data from multiple S3 sources, cleansing inconsistent data before analysis, enriching data with external lookups, or preparing data for machine learning models. 10.4 S3 and Amazon Kinesis Apache Kafka via Amazon MSK. Stream ingestion. For real-time data, S3 integrates with streaming services to serve as a long-term data landing zone. Amazon Kinesis, a platform for streaming data. Kinesis Data Firehose is often configured to ingest real-time streaming data, e.g., application logs, IoT telemetry, and automatically deliver it to S3. Integration. Kinesis Data Firehose buffers incoming stream data and then delivers it in batches to S3, optionally compressing it or converting it to formats like Parquet Orc on the fly. Benefits: reliable, scalable ingestion pipeline for real-time data that ultimately lands in S3 for long-term storage and batch analytics. Amazon Managed Streaming for Apache Kafka, MSK. A fully managed service that makes it easy for you to build and run applications that use Apache Kafka. Integration. While not a direct S3 destination like Firehose, you can use Kafka Connect, a component of Kafka that streams data between Kafka and other systems, with S3 connectors to continuously push data from Kafka topics into S3. Benefits: leverage the power of Kafka for real-time processing and message buffering, while still using S3 for cost-effective, durable cold storage of historical streaming data. Use cases: ingesting website clickstream data, aggregating real-time application logs, storing IoT device data streams, building event sourcing architectures where all events are persisted to S3. 10.5 S3 and machine learning big data services, Amazon EMR, Amazon SageMaker. S3 is the de facto storage for big data and machine learning workloads on Oz due to its scalability and cost-effectiveness. Amazon EMR Elastic MapReduce, a managed cluster platform that simplifies running big data frameworks like Apache Spark, Hadoop, Hive, and Presto. Integration: EMR seamlessly integrates with S3. You typically launch EMR clusters that read input data from S3, process it using distributed computing frameworks, and write output results back to S3. This is known as the S3-backed Hadoop pattern, or disaggregation of compute and storage. Benefits: decoupling compute from storage means you don't pay for cluster storage when the cluster isn't running, making it more cost-efficient for intermittent workloads. You can use ephemeral clusters for specific tasks. Amazon SageMaker, a fully managed service for building, training, and deploying machine learning models. Integration: SageMaker notebooks, training jobs, and inference endpoints all integrate natively with S3. Training data for ML models is typically stored in S3. SageMaker training jobs pull data from S3, generate model artifacts, and push these trained models back to S3. Benefits: provides a centralized, scalable storage for all your machine learning datasets, experiments, and model versions, streamlining the ML lifecycle. Use cases: running large-scale data transformations, building complex data analytics pipelines, EMR, training deep learning models on massive datasets, performing feature engineering for ML models, SageMaker, or orchestrating geographically distributed data processing jobs. 10.6 S3 access points, simplifying data access at scale. While direct integration is powerful, managing access to thousands of S3 buckets or object prefixes can become complex. S3 access points are a relatively newer feature designed to simplify managing data access for shared datasets in S3. What they are: access points are network endpoints attached to buckets that applications can use to perform S3 object operations. Each access point has a distinct hostname and access policy. Benefits: granular access. You can create hundreds or thousands of access points for a single S3 bucket, each with its own access policy and network controls, e.g., restricted to a specific VPC or IP range. This replaces the need for overly complex or massive bucket policies. Simplified policy management. Instead of one monolithic bucket policy, you can manage access through smaller, more focused access point policies. Scalability for shared data. Ideal for large organizations that need to grant distinct teams, applications, or users highly specific access to shared datasets within a single, very large bucket. How they integrate conceptual. An application would specify the access points ARN in its S3 requests, S3 getObject, S3 putObject, etc., rather than the buckets ARN directly. The access points policy would then be evaluated along with the bucket policy to determine access. Use cases: providing distinct sets of permissions for different microservices accessing the same data, allowing external partners tightly controlled access to specific data subsets, or simplifying cross-account data sharing within a large enterprise. Conclusion of Chapter 10. Amazon S3's true power goes far beyond simple storage. It acts as the robust, scalable, and cost-effective data backbone for a vast ecosystem of Oz services. By strategically integrating S3 with services like CloudFront for content delivery, Athena and Glue for analytics, Kinesis for real-time ingestion, and EMR SageMaker for big data and machine learning, developers can build comprehensive, highly performant, and resilient cloud solutions. The introduction of S3 access points further simplifies large-scale data access management, enabling even more sophisticated architectures. Understanding these integrations is fundamental to designing and implementing successful cloud-native applications. Our next chapter will delve into even more advanced S3 topics, pushing the boundaries of what's possible. Chapter 11. Advanced S3 topics: cross-region replication, object lock, and access points. As you delve deeper into Amazon S3, you discover capabilities that extend beyond basic storage and lifecycle management. For sophisticated enterprise solutions, stringent compliance, and highly distributed data needs, S3 offers advanced features that provide granular control, enhanced security, and streamlined operations at immense scale. This chapter explores some of these powerful, often critical advanced topics. 11.1 Deeper dive into replication, CRR, SRR, and beyond. In Chapter 4, we introduced cross-region replication, CRR, and same-region replication, SRR, as tools for disaster recovery and content distribution. Let's explore their advanced configurations and management. Filter replication by object tags and prefixes. While basic replication copies all objects, you can configure rules to replicate only a subset of your data. This is crucial for controlling costs, meeting regional compliance, e.g., only replicate specific classes of data, or optimizing storage in the destination. Prefix filtering. Replicate only objects with keys that start with a specific string, e.g., documents public. Tag filtering. Replicate only objects that have a specific tag, e.g., confidential, yes. This requires adding tags at the time of object upload or using S3 batch operations to add them later. Replication metrics and monitoring. S3 replication time, control S3 RTC. For mission-critical replication scenarios, you need to monitor the progress and latency of your replication activities. S3 RTC provides SLA, a 15-minute replication time objective with 99.99% of objects replicated within 15 minutes. Metrics, detailed metrics in Amazon CloudWatch that track the total number of operations pending replication, the size of objects pending replication, and the replication latency. This visibility is vital for ensuring your disaster recovery RPO, recovery point objective, goals are met. Handling replicated deletes and sync. By default, if an object is deleted or a delete marker is placed in the source bucket, the delete marker is replicated to the destination bucket. This means the object also appears deleted in the replica. However, you can choose to prevent deletion replication if your disaster recovery strategy requires preserving all data in the destination irrespective of source deletions. You can also configure S3 to sync changes in tags and metadata. Replicating existing objects with S3 batch replication. As noted in Chapter 4, replication rules only apply to new objects uploaded after the rule is configured. To copy existing objects in a bucket to a replication destination, you use S3 batch replication. This feature of S3 batch operations allows you to run a single job to replicate existing objects that were present before your live replication rule was set up. Replicate objects that previously failed to replicate, e.g., due to temporary errors or misconfigurations. Replicate objects from buckets that previously did not have replication enabled. 11.2 Comprehensive look at S3 Object Lock. S3 Object Lock, briefly introduced in Chapter 4, is a powerful worm. Write once read many capability designed for strict data retention and regulatory compliance. Understanding retention modes. Governance mode provides a strong layer of protection, preventing objects from being deleted or overwritten by most users. However, root account users or those with specific IAM permissions, S3, bypass governance retention, can bypass governance mode and delete or modify objects. This mode is useful for strong internal protection, allowing authorized administrators to make changes in exceptional circumstances. Compliance mode, the highest level of protection. Once an object is locked in compliance mode, it cannot be deleted or overwritten by any user, including the root account, until its retention period expires. This mode is explicitly designed to meet stringent regulatory requirements, e.g., SEC Rule 17a4. F. There is no way to bypass or shorten a retention period in compliance mode, even if you are the object owner or root user. You must wait until the specified date. Applying retention, default retention periods, you can configure a default retention period for a bucket. Any object uploaded to that bucket will automatically inherit this retention setting. This is great for ensuring all new data in a bucket meets a baseline compliance. Per object retention, you can also specify an individual retention period for each object when it is uploaded or at any time afterward. A per object setting overrides any default bucket setting. You can extend a retention period but cannot shorten it in either mode or remove it in compliance mode. Legal holds. Legal holds are separate from retention periods. They prevent an object version from being deleted. You can place and remove legal holds based on litigation, audit, or investigation needs, and they remain in effect until explicitly removed by an authorized user, regardless of any retention period set on the object. If an object is subject to both a retention period and a legal hold, S3 protects it until both are removed. Relationship with versioning. S3 Object Lock works on individual object versions. When you apply a retention period or a legal hold, it applies to a specific version of an object. If versioning is enabled and a new version of an object is created, e.g., by uploading a new file with the same key, the new version will have its own independent retention setting or inherit the bucket default, while the previously locked version remains protected by its original settings. This ensures the integrity of each specific object state over time. 11.3 S3 Access points. simpler access management at scale. Managing access to S3 for large organizations with many teams, applications, and accounts can become complex. S3 access points, introduced in Chapter 10, significantly simplify this by allowing granular access control policies without overwhelming a single bucket policy. The problem they solve. Historically, when a single S3 bucket served multiple applications or teams, the bucket policy could grow into a complex, unwieldy document. Granting varying levels of access to specific prefixes or data subsets often led to long, error-prone JSON policies. Cross-account access amplified this complexity. What they are. An S3 access point is a named network endpoint attached to a bucket that can have its own distinct access policy. You can create thousands of access points for a single bucket. Each access point has a unique DNS name, hostname, and can apply specific access rules. How they work: policy evaluation. When a request is made through an access point, S3 evaluates both the access point policy and the underlying bucket policy. For a request to be allowed, both policies must grant the necessary permissions. This provides an additional layer of security and segregation. Network origins. Access points can be configured with a network origin. Virtual Private Cloud, VPC, limits access to requests originating only from a specified Amazon VPC, ideal for internal applications and private data. Internet allows access from the internet or on-premises networks, useful for distributing public data or for cross-account access beyond a VPC. Benefits for developers. Simplified policies. Instead of one giant bucket policy, you manage many smaller, more digestible access point policies, each focused on a specific use case or application. Delegated authority allows decentralization of access management. A central team can own the bucket, while individual teams manage their specific access points for their applications. Network granularity. Easily restrict access to specific VPCs without complex IP conditions in the bucket policy. Alias for buckets. Access points can often be used as a drop-in replacement for bucket names in S3 operations, simplifying calls in SDKs or the CLI. Use cases. Microservices. Each microservice can have its own access point to a shared data bucket with an access policy tailored to its specific needs. Data lakes. Grant different data scientists or analytics tools access to specific prefixes or types of data within a large data lake, each via a dedicated VPC-restricted access point. Cross-account sharing. Create an access point dedicated to sharing a subset of data with a specific partner account without modifying the main bucket policy. 11.4 S3 Storage Lens. Deeper insights into storage usage. As S3 usage grows, understanding your storage landscape becomes a challenge. S3 Storage Lens is a cloud storage analytics feature that provides organization-wide visibility into your storage usage and activity from a single pane of glass. What it is: S3 Storage Lens offers a comprehensive dashboard with metrics, trending data, and actionable recommendations. It aggregates usage data across all your accounts and regions, offering a top-down view of your S3 footprint. Key insights provided. Cost optimization. Identifies unoptimized storage, e.g., data in expensive storage classes that is infrequently accessed, incomplete multi-part uploads, and older non-current versions. Data protection. Shows encryption status, object lock usage, and replication status. Access activity. Monitors request counts, errors, and data retrieval patterns. Capacity planning. Tracks storage growth and object count trends. Dashboards and drill down. S3 Storage Lens provides default dashboards and allows you to create custom dashboards. You can drill down from an aggregate view, e.g., all storage across all accounts, to specific regions, accounts, buckets, or even prefixes, providing fine-grained insights. Integration. Metrics are available in the S3 console, and they can be exported to S3 for further analysis using tools like Athena or QuickSight. Benefit for developers and operations. Helps identify data that can be lifecycle managed to cheaper tiers, uncover potential security risks, unencrypted data, optimize request patterns, and proactively manage storage growth. It provides the data-driven insights needed for continuous improvement of your S3 strategy. 11.5 Working with large numbers of objects. S3 inventory and S3 batch operations. When you have millions or billions of objects, interacting with S3 requires tools designed for scale. S3 inventory. This feature provides a flat file list of all objects in a bucket or a specified prefix. It's an alternative to ListObject's API operations for very large buckets, as ListObjects can be slow and expensive for comprehensive lists. How it works. S3 generates an inventory report, CSV, ORC, or Parquet format, that lists all object metadata, e.g., name, size, last modified date, storage class, encryption status, version ID, and delivers it to a designated S3 bucket on a daily or weekly basis. Use cases: auditing object metadata, compliance reporting, managing object properties, and crucially, serving as the manifest for S3 batch operations. S3 batch operations deep dive. As seen in Chapter 4, batch operations is the workhorse for mass management. When combined with S3 inventory, its power is fully realized. Manifest creation. You run S3 inventory to get a list of all objects you care about. Operation execution. You then feed this inventory report, or a filtered version of it, as a manifest to an S3 batch operations job. You select an operation, e.g., copy, tag, delete, restore Glacier objects, invoke Lambda on each object, modify object access control lists. Scalable automation. S3 batch operations handles the orchestration of performing that operation on potentially billions of objects, managing retry logic, and providing detailed success failure reports. Example: a developer needs to change the storage class of 50 million objects that are currently in S3 standard to S3 Zone IA because business requirements changed, and previous lifecycle rules don't cover them. He generates an S3 inventory report. He loads the report into Athena to filter for the specific objects that need to be changed. He saves the filtered object list as a new manifest. He creates an S3 batch operations job, points it to the manifest, and selects the replace storage class operation. S3 handles the rest. Conclusion of Chapter 11. The advanced features of Amazon S3, from fine-tuned replication and unyielding object lock for compliance, to simplified access management with access points, and large-scale insights with Storage Lens, demonstrate its maturity and depth as a cloud storage service. Coupled with tools like S3 inventory and S3 batch operations, developers gain unprecedented control and automation capabilities for even the most complex and vast datasets. Mastering these features is essential for building highly performant, secure, compliant, and operationally efficient cloud solutions. We have now covered the breadth of S3's capabilities. In our final chapter, we will consolidate this knowledge into practical best practices, explore troubleshooting techniques, and ponder S3's exciting future. Chapter 12. Best Practices, Troubleshooting, and the Future of S3. We've embarked on a comprehensive journey through Amazon S3, from its foundational concepts to its most advanced functions and integrations. This final chapter synthesizes that knowledge, providing actionable best practices for developers, offering guidance on common troubleshooting scenarios, and peering into the future role of S3 in the evolving cloud landscape. 12.1 S3 Best Practices Roundup for Developers. A robust S3 implementation isn't accidental. It's the result of adherence to proven best practices across several key dimensions. 12.1.1 Security Best Practices. Principle of Least Privilege. Grant only the minimum necessary permissions to IAM identities and S3 bucket policies. Regularly review and audit these permissions. Use IAM roles. For applications running on AWS Compute Services, EC2, Lambda, ECS, always use IAM roles for authentication. Never embed or hardcode long-lived access keys. Enable bucket-level public access blocks. As a crucial line of defense, enable all 4 public access block settings at the account level by default. Only selectively disable them for specific buckets, like static website hosting origins that sit behind CloudFront, where public access is explicitly required and controlled. Encrypt data by default. Enable default encryption on all your S3 buckets. Choose SSE S3 for ease of use or SSEKMS for more control and auditing capabilities. Enforce HTTPS transfer. Always use HTTPS for all interactions with S3 to protect data in transit. Oz SDKs and CLI default to this. Ensure custom implementations do as well. Enable server access logging and CloudTrail. Log all S3 API, CloudTrail, and S3 object access logs, activity for auditing, monitoring, and forensic analysis. Store logs in a separate, secure audit bucket. Use S3 access points. For complex, shared datasets, leverage access points to simplify granular access policies over relying solely on complex bucket policies. 12.1.2 Performance Best Practices. Utilize CloudFront for public content. For any publicly accessible content, use Amazon CloudFront as a CDN to cache data at edge locations globally, reducing latency and offloading S3. Leverage multi-part uploads. For files larger than 100 MB, ensure your applications use multi-part uploads for faster and more reliable transfers. Oz SDKs often handle this automatically. Employ S3 transfer acceleration. If you have geographically dispersed users or uploaders, consider S3 transfer acceleration to speed up transfers over long distances. Parallelize operations. For high-throughput scenarios, design applications to perform S3 operations, uploads, downloads in parallel using concurrency. Optimize object key structures. While modern S3 handles high request rates for any prefix, designing logical and well-distributed key structures still aids in organization and can passively contribute to performance. Use S3 Select. When only a subset of data is needed from large objects, use S3 Select to filter data directly in S3, reducing data transfer and processing time. 12.1.3 Cost Optimization Best Practices. Match storage class to access patterns. This is the single biggest lever for cost savings. Use S3 Standard for frequently accessed data, Standard IA1 Zone IA for infrequent, and Glacier Deep Archive for cold archival. Transition data proactively. Implement S3 lifecycle rules. Automate the transition of objects to cheaper storage classes as they age, and automatically expire, delete data that is no longer needed. Manage non-current versions. If versioning is enabled, set lifecycle rules to expire non-current versions to prevent storage costs from accumulating indefinitely. Optimize data transfer out. Keep data access within the same AWS region AZ where possible. Utilize CloudFront for public delivery, as data transfer from S3 to CloudFront is free. Compress data. Compress files before uploading to S3 to reduce storage consumption and subsequent data transfer costs. Monitor with S3 Storage Lens. Use Storage Lens to gain insights into your S3 usage across your organization, identifying opportunities for cost optimization and compliance. 12.1.4 Reliability and Data Management Best Practices. Enable versioning. Always enable versioning on buckets containing critical data to protect against accidental deletions, overwrites, and to maintain object history. Implement cross-region replication, CRR. For critical data that requires disaster recovery capabilities, set up CRR to asynchronously replicate data to another AWS region. Utilize S3 Object Lock. For compliance or critical data immutability, use S3 Object Lock in governance or compliance mode with appropriate retention periods. Implement robust error handling. Design your applications to gracefully handle S3 errors, including retries with exponential backoff and logging for debugging. Manage incomplete multi-part uploads. Regularly review and clean up stalled multi-part uploads to avoid incurring unnecessary storage costs. Use S3 Inventory for auditing. For large buckets, leverage S3 Inventory reports to get a comprehensive list of objects and their metadata for auditing and planning batch operations. 12.1.5 Organization and Governance Best Practices. Consistent naming conventions. Establish clear and consistent bucket and object key naming conventions for better organization and easier management. Tagging. Use S3 bucket and object tagging for cost allocation, resource categorization, and policy enforcement. 12.2 Common S3 Troubleshooting Scenarios. Despite S3's robustness, you might encounter issues. Here's how to approach common problems. Access denied, errors. Check IAM policies. Is the IAM user or role attempting the action authorized to perform it on the specific bucket object? Least privilege. Check bucket policies. Does the bucket policy explicitly allow the action? Is there an explicit deny statement anywhere, which always overrides an allow? Public access blocks. Are the S3 public access block settings preventing public or cross-account access that you might be trying to grant? Check both account level and bucket level settings. Object ACLs. Less common, but check if an ACL on the specific object is restricting access. Encryption key permissions, SSEKMS. If using SSEKMS, does the IAM entity have permission to use the KMS key for encryption decryption? Cross-account role trust. For cross-account access, ensure the trust policy on the IAM role in the destination account allows the source account to assume it. No such key, object not found errors. Correct key name, S3 keys are case sensitive. Verify the exact key name, including any folder prefixes. Delete markers, versioning. If versioning is enabled, a no such key might mean a delete marker exists for that object, making its latest version appear deleted. You might need to retrieve a specific previous version. Eventual consistency. For new objects or deletions, S3 provides read after write consistency for new object puts in all regions, and eventual consistency for other operations, overwrites deletes. Very rarely, a subsequent GET might not immediately reflect the latest state. This is typically transient. Region mismatch. Ensure your application is trying to access the bucket in the correct AWS region. Performance issues, slow uploads, downloads. Distance to region. Is the client geographically far from the S3 bucket's region? Consider transfer acceleration or CloudFront. File size. Are large files being downloaded in parts, multi-part? Ensure SDKs are configured to leverage this. Concurrent operations. Are you parallelizing operations effectively? Throttling. Are you exceeding S3's request limits? Unlikely for most applications, S3 is designed for high throughput, but possible for extremely aggressive patterns. Check CloudWatch metrics. Network bandwidth. Is the client's internet connection or the server's network bandwidth a bottleneck? Cost spikes. Review CloudWatch metrics. Examine S3 storage usage, request counts, PUTS, GETS, ListS, data transfer out, and retrieval metrics. S3 Storage Lens Cost Explorer. Use these tools to identify which buckets, prefixes, or activities are contributing most to the cost increase. Look for data in expensive storage classes that is infrequently accessed or unexpected data transfer. Using S3 access logs and CloudWatch metrics for debugging. S3 access logs provide granular detail on every request to your bucket. Who made the request, when, what operation, success, failure, IP address, user agent. Crucial for security audits and traffic analysis. Amazon CloudWatch. S3 publishes various metrics to CloudWatch, e.g., bucket size, object count, request counts by type, byte transfer. Monitor these for trends, anomalies, and to set up alarms. 12.3 The Future of S3. Emerging trends and its enduring role. Amazon S3, a service that predates many internet companies, continues to evolve rapidly. Its future role in cloud computing is not only secure, but expanding to meet new paradigms. The global data lake. S3 will increasingly be the central, primary data store for global, multi-region data lakes, serving as the source for all analytics, machine learning, and AI workloads. Its ability to store any data type, scale limitlessly, and integrate seamlessly makes it indispensable. Fueling serverless and edge computing. S3's tight integration with serverless compute, Lambda, will deepen, enabling even more sophisticated event-driven architectures at massive scale. As edge computing grows, S3 will play a larger role in data ingestion and storage at the edge, facilitated by services like AWS Storage Gateway and AWS Outposts. Beyond objects, towards semantic understanding. While S3 stores objects, the trend is towards enabling even more intelligent interactions with those objects. Services like S3 Select will become more powerful, allowing complex queries across diverse formats. AI ML services will further integrate to automatically extract meaning, tag, and derive insights directly from data as it's stored in S3, making the data inherently smarter. Continued cost and performance optimization. Expect S3 to introduce even more granular storage classes, smarter intelligent tiering, and further performance enhancements, e.g., faster reads for certain access patterns, more optimized write paths, enhanced data governance and security. With ever-increasing compliance demands, S3 will continue to provide advanced governance features, like object lock enhancements, and integrate with new security paradigms, ensuring data protection in an increasingly complex threat landscape. S3 access points are a prime example of this evolution. S3's journey from a simple storage service to the foundational data layer of the cloud is a testament to its robust design and continuous innovation. Its versatility and scalability have made it the go-to choice for storing virtually any type of data for any application. 12.4 Beyond this book, resources for continued learning. The world of cloud computing, and S3 along with it, is constantly evolving. To stay current and deepen your expertise, here are some invaluable resources. Official AWS documentation, the most authoritative source. The S3 User Guide, Developer Guides for Oz SDKs, and the S3 API reference are meticulously updated and contain comprehensive details. Oz Blogs, AWS Storage Blog, AWS Developer Blog, AWS Architecture Blog. Regularly publish deep dives, best practices, announcements of new features, and practical use cases for S3 and other AWS services. Oz Ray, Invent, and AWS Summits. Keynotes, breakout sessions, and workshops from these annual conferences offer cutting-edge information and real-world implementations. Most are available on YouTube. AWS Certified Solutions Architect/Developer Associate. Pursuing certifications encourages a broad and deep understanding of AWS services, including S3. Oz Well-Architected Framework. This framework provides guiding principles for designing and operating reliable, secure, efficient, and cost-effective systems in the cloud. Review the Storage Lens section in the Well-Architected docs. AWS Training and Certification, official courses provided by Oz, community forums and online resources, active developer communities, Stack Overflow, Reddit, specific tech blogs, often provide real-world insights and solutions to common challenges. Thank you for embarking on this journey through Amazon S3. By applying the knowledge and best practices gained from this book, you are well equipped to leverage S3's immense power to build the next generation of scalable, resilient, and cost-effective cloud applications. Embrace continuous learning and happy building.